Okay, now some sand dunes of different structures may be formed, all because of direction of the wind. When the wind is coming from below and such sand dune is formed, it is known as a bastions. Okay, when the wind is changing the direction, when the wind is not coming from here, instead of when it is going from here, so it will be arranged accordingly. It will be arranged in this manner. It is known as longitudinal sand dunes. Okay, when the sand is coming from below and it is forming a structure wherein the one side is gentle sloping, one side is steep sloping, it is known as transverse sand dune. And when the sand dune is formed along the coastal area where the sea breeze along with that of the vegetation is leading to the formation of this type of sand dune, it is known as the parabolic sand dunes. Okay, so here some important landforms we did, and just one liner was important. You are really not expected to go much into detail. Now this is just to make sure that you are not leaving anything. At the same time, you are not going too much into the detail of those topics wherein less probability of question is there. More question shall be asked from those aspects which is very dynamic, like for example climatology. So we'll just start with the climatology now. So in climatology, it is seen that almost every year UPSC asks question, and in the recent few years also consistently they've asked question from last 5 years. So this is more dynamic, more there in the news, and more chances of question being asked. Climatology forms basis of your Indian climate and climate change. Okay, so there is a lot of concept related to climatology, even the oceanography, even the distribution of the biomes of the world as well as India is related to climatology. So let us focus over here. So what type of question is being asked? Structure of the atmosphere. They have asked question on the stratosphere, ionosphere, and last year they had asked question in the mains in the troposphere. Okay, mains question. So we must be doing all the important layers. They have asked question related to thickness of the atmosphere. This is directly taken from the NCERT. With respect to the heat budget, they have asked question on the heat budget and the insolation. You can collectively take it. With respect to the insolation that is being received, and different insolation, that is infrared, visible spectrum, UV radiation, question is being asked. The question have been asked on albedo. Okay, so what is an albedo? What is the varying proportion of the albedo on the different parts of the world, on different landscapes? Then they've asked question on the temperature distribution of the world. So here with respect to the temperature distribution, you can see 2023 there was a question related to the thermal contrast or the temperature contrast between the continent and the ocean, and here also you can see similar question, annual range of temperature. So that is basically the thermal contrast. Statement 1, you can see thermal difference. Then again annual range of temperature, and question related to the similar topic. So you can expect question related to this, very concept based question. Then with respect to the increasing altitude, the temperature pressure relation, temperature and the altitude relation, the pressure and the altitude relation, pressure belt, this also holds important here. With respect to the important jet streams, important jet streams will be taking care in the Indian climate, because most of the fundamentals of the jet streams is directly related to the monsoon. Okay, so we'll do that in detail there. Okay, similarly they have asked question with respect to horse latitude. They have asked question related to the westerlies and the easterlies. Okay, and in the recent year also they had tried to confuse the student by asking little confusing question here in the winds, especially this question number 21. This was quite confusing to the students with respect to the trade winds and the westerlies. Okay, similarly this question 2015, this was also a trap question. Okay, so at times there are trap questions. You just have to keep the temperament cool enough in the exam hall, and you can attempt these questions also. So they've asked question on the westerlies. So almost on all the major winds, the wind pattern, they have asked questions. Okay, they have asked question again. Westerlies in the southern hemisphere, that is roaring 40s. Local winds, they've asked question on the local winds and the regions. So match the column kind of question. Again, a local wind in statement 2, you can see Harmattan. Okay, so again, wind related question and the impact of the wind with respect to that of the formation of the deserts. Okay, and not just one, in fact 2 question, and not just in prelims and mains also the same question was asked. So topic is same, question is either framed in prelims or in mains. Then not many question in humidity, but yes, clouds, you can see 2020 they had asked question with respect to the impact of the high clouds and the low clouds, and with respect to that of the cirrus cloud thinning technique. So this have got overlapping in 2 topics here, climatology also and global warming. Then cirrus cloud related they've asked previously also. They've asked question related to the cloudy nights, which is relatively warmer, so what could be the reason. And 2019 they've asked question related to dew drops. Okay, when it comes to thunderstorms, they've asked question related to thunderstorms, lightning and thunder. Okay, so not no question on the rainfall pattern, but cyclone and anticyclone they have asked question. So here in the case of the cyclones, the what is the reason where some regions have cyclones, some regions do not have cyclones. Then the characteristic of the cyclone they have asked question. Okay, what is the impact of the cyclone? And at times these are there in the news, current affair based questions. So for example, this hurricane which was there in the news was being asked, and cyclone related mains question was also there from the current affair. Especially in the last 2 years ago, they had asked question related to the tropical cyclones. Now climatic region of the world, this is the place where the entire crux of climatology comes into picture, and all the concept will be tested over here. We have different parts of the world with the different climatical conditions, and you can see there are questions. Even the recent question is being asked from the climatic regions of the world. So you have to be very well prepared with this topic. In last 20 years there were roughly 47 questions. So 47 questions in last 23 years. So that indicates UPSC have good inclination toward this topic. So on an average you can expect 2 questions from here. Okay, if we take the normal trend, geomorphology was not so frequently asked topic. So we'll switch to the discussion climatology. Now whenever you are preparing for prelims or for mains, always do analysis. Level 1 analysis should be broader analysis of the whole subject. Okay, that is which subject is more important, which topic is more important. Having done that analysis, you should be focusing on those topics in detail, within the topic what dimension of question have been asked. Because if you do not do this, you will never know where to draw the line. You will never understand where to stop, how much in depth you are supposed to go. So it is always advisable, always do analysis broadly and then go into the detail. For example, in the beginning we did the analysis of geography as a whole, which all important topics were there and the frequency of the number of questions, and then we are taking each topic, and before starting each topic we are doing analysis of that topic only, that topic subtopics, dimension of the questions, and then we are studying. So this will make our preparation more organized, systematic, and concept based questions are always repeated. Okay, from last so many years, since the beginning when the UPSC is taking exams, so certainly they would have asked concept based questions from every area by now. Yes or no, every subject. So what will they do if they have to ask concept based question? They will be repeating from the previous year only. Okay, certainly they will be repeating from the previous year. So you have to like do previous year question for two reasons: for understanding the depth of the subject, and second is some question will be repeated. Okay, so let us begin with this. So with respect to the evolution of the atmosphere, the way we did evolution of the universe, evolution of the interior of the earth, it is also advisable we must do evolution of the atmosphere. So initially when the earth was created, it was very, very hot, then it cooled, then the interior of the earth, from the interior of the earth, different gases came out, degassing phenomena happened, degassing, and initially the atmosphere was only hydrogen and helium, but later on these gases were added: carbon dioxide, hydrogen sulfide, methane and ammonia, and the water vapor. Okay, and when these gases came up, the condensation of these gases took place and precipitation, and by that the ocean was created. Okay, but these early atmosphere is not what we happen to see today, because there are several changes that have taken place. These changes have been taken place because of the solar heat waves, which stripped away the earth atmosphere and reduced it to a very thin layer of the atmosphere. Second modification was being done by the living organism. So we have already understood this evolution, that is the cyanobacteria, blue-green algae, aquatic animals, then amphibians. So all of these were responsible for changing the proportion of the carbon dioxide and the oxygen. Carbon dioxide, which was maximum, is reduced to just 0.03% now. Oxygen, which was very less, is now increased to 21 to 21%. Okay, so now because of the carbon dioxide getting mixed with the water, the carbon dioxide in the atmosphere got reduced, and because of that, earth, which was very, very hot, became cooled over a period of time. Now what we are doing, we are reversing the trend. Now we are now releasing more amount of carbon dioxide in the atmosphere than the environment's carrying capacity. Okay, because of that, global warming and climate change phenomena is happening. Now with respect to the like trend, if we see, early atmosphere, which was carbon dioxide, hydrogen sulfide, methane, water vapor, got modified, and modification took place because of several reasons: solar waves, living organisms, weathering, volcanisms. And presently we have this atmospheric composition where nitrogen is 78%, oxygen is roughly 21%, so they two collectively makes 99%. Then we have argon, which is 0.93%, carbon dioxide 0.03%. Now everyone knows the initial four gases: nitrogen, oxygen, argon, carbon dioxide, but students usually do not memorize this. So try to memorize this also. Okay, everyone will remember this. UPSC will ask question here to arrange them in the descending order. So this is collectively just 1%. So they are too much like and small in proportion, and like a lot of decimal numbers are there. So do not remember them. Just remember the descending order: neon, helium, krypton, xenon, and hydrogen. Okay. So in the future, a human induced factor is going to dominate, and this atmospheric composition is going to change. So if we take the natural factor, plate tectonic, volcanism, meteorite impact, solar heat waves, photosynthesis, respiration, and anthropogenic, that is industrialization, automobiles, change in the land use pattern. Okay, industrialization, especially the coal-based thermal power plant. In the case of India, we have more than 50% of electricity generated because of coal-based thermal power plant. So it is the largest sector for release of the carbon dioxide. Certainly, it is going to play a very, very important role in terms of changing the atmospheric composition. Okay, so it is very, very important that the atmospheric composition should be not altered. Environment have its own carrying capacity. Okay, it will convert some carbon dioxide into oxygen, but not much beyond its limit. So here, with respect to this insolation, incoming solar radiation, the sunlight which is coming, the radiation that is coming from sun towards the earth is very important. Last year there was one question related to the insolation, very technical question. Okay, many students found it very, very difficult, but these are all concept based question. UPSC is going into the detail now. They're not asking question from like a new topic, because whatever is the syllabus given, they are asking from the within the syllabus only, but they are going into the depth of the subject now, because they are exhausted with asking the same simple repeated fact based question, one liner question. Okay, they are exhausted now. They are asking very difficult question, but topic will be same. So it is expected that you should go into the detail. So with respect to the insolation, which is incoming solar radiation, so sun, which is like we have seen the in the case of the sun, the hydrogen fusion reaction takes place, and the heat energy is being released. This heat energy travel all the way on an average 150 million kilometer and reaches the earth. So incoming radiation, incoming solar radiation that the earth receives, okay, that the earth receives is just 2 calories per centimeter square per minute. Okay, every minute in every one centimeter square area we receive 2 calories of energy. If we try to take the further conversion, we can understand that it is around 164 to 340 watt per meter square per day. Okay, 164 to 340 watt per meter square per day. If we take the whole year, so it is roughly 180 million gigawatt of energy, which is much more than the human requirement. Okay, present human requirement. Okay, out of whatever is the amount of the radiation emitted by the sun, only 2 billionth part, that is, let us say 2 billion unit of radiation is being emitted out. So only 1 unit is being received on the earth. So imagine if more insolation is coming towards the earth atmospheric temperature will certainly be increasing. The incoming radiations, now radiations, that is a wave. Okay, radiations have particular characteristics. It have it's a certain wavelength, it have got frequency, it have got time period. Okay, and it can travel through certain medium. Okay, so radiation travel through vacuum and in medium, both. It can travel with medium, without medium, both, because between sun and the earth there is, like beyond the earth atmosphere, it's all vacuum. So it travels in the vacuum plus earth medium, that is the earth atmosphere, that is a gaseous medium. Okay, so the incoming radiation is a short wavelength radiation, the outgoing radiation is a long wavelength radiation. Okay, short wavelength radiation usually do not cause heating of the atmosphere. Outgoing radiation, the radiation which has been reflected back from the surface of the earth, it gets converted into from the short to the longer wavelength. This long wave radiation is responsible for atmospheric heating. It takes roughly 8 minutes and 20 seconds for the insolation to reach the Earth's atmosphere. Okay, so what are the radiation that we receive? So radiations that we receive, electromagnetic spectrum. In the electromagnetic spectrum, if we see, so there is gamma rays, X-rays, visible light, UV radiation, visible, infra, micro and radio waves. Okay, so it is gamma, X-rays, UV radiation, then visible, infra and micro and the radio waves. So here in this case UV radiation, visible and the infrared, this is very important to us, because this is what is maximum received from the insolation. Okay, so here if we take UV radiation, so we receive in the insolation roughly 5% of UV radiation, 42% of visible radiation, 53% of infrared radiation. Okay, 5% UV radiation, 42% visible radiation and 53% of infrared radiation. Okay, out of these, through visible light we are able to see the objects, but visible light is not responsible for heating. What is responsible for atmospheric heating? It is the infrared radiation. Infrared radiation is responsible for atmospheric heating. Very, very important prelims question. Okay, this was a prelims question. Now let us just this was a prelims question, so let us just understand this wavelength. If you take the case of the wavelength, okay, so the UV radiations have the wavelength less than 380 nanometer, visible 380 to 700 nanometer, and infra 700 to 1 lakh nanometer. Okay, no need to remember the data or the value, just remember UV radiation less or a smaller wavelength followed by visible radiation followed by infrared radiation. Then frequency and wavelength are inversely proportional to each other. So if the wavelength is less, frequency is more, and if the wavelength is more, frequency is less. Okay, that some facts. Again, this was asked in the UPSC. So at zenith is basically when the sunlight is just above overhead. Okay, maximum. So at zenith, at the sea level, sunlight provides energy of 1 kilowatt per square meter. 1 kilowatt per square meter. Of that, okay, if we divide it proportion wise, 5% UV, then 42% visible, and the remaining is the infrared radiation. So 32 watt is UV radiation, 445 watt is visible radiation, and 527 watt is infrared radiation. Okay, UV radiation. Let us understand some more thing about UV radiation. With respect to the UV radiation, that is ultraviolet radiation, it is basically of 3 types, A, B and C. The A radiation is responsible for skin aging and cancer. B, you must have heard that vitamin D you can get from sunlight. Okay, so sunlight basically synthesizes the skin, okay, for production of vitamin D. Vitamin D is produced within our body, and the production mechanism that is triggered by the sunlight. Which one? UV rays B. Okay, UVB radiation. But it can at times also cause cancer, skin cancer. Okay, and C, very little of that reaches the earth. Okay, UV radiation, most of the UV radiation is captured by the ozone layer. You must have heard. Most of them is captured by ozone layer. So ozone layer is the layer that is there in the stratosphere, roughly 30-32 kilometer. So this is a thin layer which absorbs the ultraviolet radiation, and the fragmentation of the ozone takes place, and further the filling of the ozone also takes place. What if the UV radiation is reaching the earth? What if there is a ozone hole and it is not being filtered, it reaches the earth? So it will cause skin aging, cancer, okay, and there are a lot of other related problems will come. Plus it will also kill microorganism in the bacteria. It will kill micro in the soil, sorry. So it will kill microorganism in the soil. So because of that, what will happen is bacteria, when it is being killed from the soil, so soil fertility will be reduced. Okay, soil fertility will be reduced. So it is important that ozone layer should be intact. Infrared radiation, so it is basically infrared radiation which is being absorbed by the greenhouse gas, which causes atmospheric heating. Okay, so visible light, UV radiation, infrared radiation have the respective different applications. Greenhouse gases, especially carbon dioxide, water vapor, methane, sulfur dioxide, nitrous oxide, all of these absorb infrared radiation. On different parts of the earth, same amount of insolation is not reaching. So insolation variation is there because of rotation of the earth, because of angle of incidence. So you must be knowing that this earth is tilted by certain degree, 23.5 degree. Let us say if the tilting is more or less, then amount of the sunlight receiving on the earth would also be more or less, would also be varying. Length of the daytime during summer, the let us say it is summer in the northern hemisphere, so north is hemisphere is tilted towards the sun, so the day is longer, more insolation will be received. Okay, in the similar manner, when it is winter, so the north hemisphere is tilted away from the sun, so less amount of the insolation is received, the length of the daytime is relatively smaller. So transparency of the atmosphere is also important. If it is a cloudy atmosphere, if it is cloudy atmosphere, so most of the sunlight will be reflected from the surface of the clouds. It will be reflected from the surface of the clouds. Okay, so less amount of insolation. The transparency of the atmosphere is important. Then configuration of the land and the ocean. Okay, the configuration of the land and the ocean is also important. See, land heats up faster because specific heat is less. Ocean heats up slowly. Water have got more specific heat. Okay, so so the region in accordance with the land or the water would also be responsible. So let us consider ocean. Ocean water will be evaporating. Evaporation say cloud formation. Cloud formation say again this thing will happen. Again albedo effect will be increasing. So region which is like oceanic region will be receiving less amount of insolation because of cloud formation. Land wala region, so less cloud formation and more amount of sunlight reaching the surface. Then distance of the earth from the sun, we know that earth is revolving in the elliptical manner. At times it is close, at times it is far. So it is close enough on the 3rd or 4th of January, that the closest distance, that is perihelion, 147 million kilometer. Farthest distance is 152 million kilometer, that is on 4th of July, that is aphelion. So when it is close, certainly more insolation will be received. When it is far, less insolation will be received. Okay, so in the tropical region, so we receive more of 320 watt per meter square per day. Okay, and within the tropical region, desert region will receive more sunlight, because desert region cloud formation is not there. It is a clear sky. More insolation will be able to penetrate the atmosphere and reach the surface. Polar region less 70 watt per meter square per day energy would be received. So if we compare pole and tropics, so roughly 4 to 5 times energy or the insolation is received in the tropical region as compared to that of polar air. Okay, let us proceed ahead now with respect to heat budget. Okay, heat budget. So heat budget, it is the amount of the sunlight that is coming and going. So if you take with respect to the sunlight, consider 100 unit of the sunlight coming towards the earth. Okay, of that 100 unit of the sunlight, 6 unit of the sunlight is reflected from the dust particles in the atmosphere, 27 unit from the surface of the cloud, and 2 unit from the snow covered mountain. So if I add this, it is roughly 35 units. So 35 unit of the sunlight is reflected back, and it is not responsible for atmospheric heating. This 35 unit of sunlight is called as the albedo. Okay, albedo is the reflected sunlight. Now remaining 65 unit. So out of 65 unit, 14 unit is absorbed by the atmosphere. Remaining 51 unit is actually receiving on the surface of the earth. So this 51 unit is responsible for the surface heating. This 51 unit is responsible for surface heating, and when this this 51 unit being released back into the atmosphere. Okay, so when it is coming, it is incoming short wave solar radiation. When it is going back, this short wave get converted into long wavelength. So when it is coming, it is solar radiation. When it is going back, it is no longer solar, it is terrestrial radiation. Are you understanding this? Take on. Incoming one is short wavelength, outgoing one is long wavelength. So terrestrial radiation is not directly being released into the space. Some unit is again being captured by the atmosphere, and this collectively forms 48 unit. This is responsible for atmospheric heating. So this phenomena takes place during the daytime. So at night time, what happens is this 48 unit is re-radiated back into the space. Okay, and some 17 unit is directly radiated into the space. Okay, so this 17 unit, 48 unit, okay, collectively 65 unit will be responsible for atmospheric cooling. So in this way, whatever amount of sunlight had come is again going back into the space. Okay, so when entire unit of sunlight is going back in the space, how is the atmospheric heating taking place, or how is the global warming taking place, or why is the global warming taking place? See, what happens is when the greenhouse gas is going back into the space, what happens is this greenhouse gas is being captured by the this greenhouse gas captures the terrestrial radiation. Yes or no? So if there is more greenhouse gas, more absorption of infrared radiation will be taking place, more atmospheric heating, and this will disturb the whole of the heat budget. So the stay time of this radiation in the atmosphere will increase. This increased stay time will be responsible for the global warming. So it is not that the amount of heat energy will keep on accumulating, okay, because Earth is so old. Had it happened in the past, then by now the Earth would have become, non-habitable, isn't it? Or would have become so hot by now. So the greenhouse gas is increasing the stay time of this radiation from being released back into the space, okay, which in turn is very, very harmful. Now the amount of the insolation, we studied that in the tropical region it is relatively more as compared to that of the polar region, which is quite less. So what happens is heat energy. So heat energy gets disbalanced in this case, surplus at some and deficit at some. So there is this process wherein the heat energy is being transferred from surplus to the deficit region. Okay, because of this transfer, the latitudinal heat budget is balanced. Okay, latitudinal heat budget is balanced. Else what would happen is the heat accumulation will keep taking place over here, deficiency will continue over here, and the very, very contrasting phenomena will take place on the Earth. Both would be very difficult for the survival. Okay, it is time that we should do a few questions. Here, if we can do question number 4, please. Question number 4, which was just asked last year. So it says, with reference to the Earth atmosphere, which one of the following statement is correct? Just try to focus on each statement. Option A says the total amount of the insolation received at the equator is roughly about 10 times the received at pole. So it is not 10 times. We saw equator, tropical region, so it was roughly like 320, and the polar region is roughly 70, so it is 4 to 5 times, not 10 times. Second is infrared rays constitute roughly 2/3 of the insolation. So we saw that infrared was roughly 53% something, not, and 2/3 is 66%. This is wrong. See, infrared waves are largely absorbed by water vapor that is concentrated in the lower atmosphere. Infrared waves are largely absorbed by greenhouse gases that is concentrated in the lower atmosphere. This is true. Yes, that causes atmospheric heating. And last, infrared waves are part of visible spectrum of electromagnetic waves. See, UV radiation have a different set of frequency and wavelength. Visible light have different set of frequency and wavelength, and infrared have different set of frequency and wavelength. They do not overlap each other, or they are not part of each other. Are you understanding this? So this statement, infrared waves are part of visible spectrum of electromagnetic waves of solar radiation, wrong? Okay, I hope you are understanding this. This was a tough question, quite a tough question. Okay, let us proceed ahead with another question now. Here, question number 5. So question number 5, consider the following statement. The albedo of an object determines visual brightness when viewed with reflected light. So what is, how do we see an object? We are able to see object because of reflection of the light, and albedo is also the reflection. Yes or no? So this is correct. Albedo of Mercury is much greater than that of the albedo of the Earth. See, albedo is reflected light. More reflection, less absorption. Less reflection, more absorption. So with respect to that of the sequence, Mercury, Venus, Earth. Okay, so Mercury is closest to the Sun, followed by that of the Earth. And since Earth have atmosphere, and in the case of Earth's atmosphere, much of the 35 unit of the albedo is reflected back. So which keeps the Earth relatively warm enough, not hot, not too cold, warm enough for the survival of living organism. On the other hand, Mercury is relatively more hotter. More hotter means more absorption would have taken place, means less of albedo. So albedo of Mercury greater than Earth? No, it is less. Okay. Then this is quite simple. Which one of the following reflects more sunlight or albedos compared to that of the other three? So reflection will be more from the white color, and fresh white snow. Fresh snow is basically white in color, so more reflection. Okay, let us proceed with the initial few questions. Before that, let us do the structure of the atmosphere. Structure of the atmosphere. See, Earth atmosphere, the way we studied the geomorphology, wherein we studied the interior of the Earth, static model, dynamic model, and in the static model we saw the different layers, the crust, mantle, and the core. Here also there is basically two method of classification. One is one basis of the classification is the physical, and the another one is the chemical. Okay, so over here, on the basis of the physical property, it is being classified into the troposphere, stratosphere, mesosphere, and thermosphere. On the basis of chemical properties, divided into homosphere and heterosphere. So homosphere and heterosphere. So homosphere is basically that layer of the atmosphere which is having relatively uniformity in terms of the chemical composition. And heterosphere is that layer where everything is mixed up. Okay, mixed atmosphere, mixed layer of the atmosphere. Okay, now here in the case of the physical properties, physical composition, question are more troposphere, stratosphere, mesosphere, and thermosphere. We'll try to understand each of these first in a nutshell and then in depth. Okay, so here with respect to troposphere, so troposphere is roughly 8 to 18 kilometer thick from the Earth, and which is followed by the stratosphere, which is roughly up to 50 kilometer from the Earth atmosphere surface, and then followed by the mesosphere, and then the thermosphere, which is further divided into ionosphere and exosphere. Troposphere. Now this graph that is seen is basically the temperature graph. As the altitude increases, temperature fluctuates. It decreases in the case of troposphere. In the case of stratosphere, temperature increase, then decrease, that increase. So what is the reason behind each of these? We'll understand. So temperature is not constantly increasing or decreasing, it is fluctuating. But pressure and density, they are constantly decreasing. Okay, they are constantly decreasing. Do you remember that when we studied geomorphology, when we go in the interior of the Earth, temperature, pressure, density all increases. So I hope you remember temperature increases by 30 degree per kilometer, and in the case of the Earth atmosphere, the temperature decreases by 6.5, especially in the troposphere, not in all the layers. Okay, so let us go into each of these layers, troposphere, stratosphere. But before that, let us know something about each of these gases. Nitrogen is 78% in the atmosphere. It is stable, it is non-reactive. Okay, it is very, very important for the life, because nitrogen fixation that is being done by the bacteria creates food for the plants. Okay, so nitrogen cycle starts from there. Carbon dioxide is 0.03. It is important greenhouse gas. Up to 90 kilometer it is found. Water vapor is very, very important. Up to 90 kilometer it is found. And water vapor is also an important greenhouse gas. And the water vapor concentration will be more in those regions where the water bodies is there plus heating is there. So it is more in those warm and wet tropical region, and water vapor is relatively less in dry and the polar region. Polar region have snow and they have ice, but water vapor is something that is found in the atmosphere. So when the sunlight is not there, how the melting will be taking place? So it is found in those regions which is dry and especially those very cold region. From equator, if you go towards pole, amount of water vapor decreases. From low altitude to higher altitude, if you go, amount of water vapor decreases. So as latitude increase, water vapor decrease. As altitude increase, water vapor decreases. Last is the dust particles. It is very, very important for precipitation for various atmospheric phenomena. Dust particle is important from environment perspective. So it is high in the case of subtropical and the temperate region, and in the case of low latitude, in the case of equatorial and polar region, it is relatively less. Okay, equatorial region, the rainfall is high, but because of everyday rainfall, the amount of dust particle have reduced. Troposphere. Now, with respect to the thickness of the atmosphere, especially in the terms of troposphere is 8 to 18 kilometer thick. It is 8 kilometer in terms of the polar region, 18 in the equatorial region. So this is how the troposphere looks like. It is thick in the polar equatorial region, and it is relatively thin in the polar region. So in the case of the equatorial region, it is 18 kilometer and maximum thickness is at the equator. Maximum thickness is at the equator because sunlight is there mostly in the tropical region for most part of the year. So because of that, the air becomes hot air becomes light, and the air start to rise up. In the polar region, sunlight is not intense, the air is relatively cold, the air do not rise to a greater height. Okay, so maximum thickness at the equator. Okay, 18 kilometer. In terms of the temperature gradient, temperature. So as the altitude increases, what happened? Temperature decreases. We had studied it decreases at the rate of 6.5 degree per 1 kilometer or 1 degree Celsius per 165 meter. Okay. Now this rate may change from region to region, and from season to season this rate may change. Now with respect to that of the thickness of the atmosphere, we saw with respect to the temperature gradient, as altitude increases, what did we study? Temperature decreases. Okay, at the equator, what did we study? The thickness is maximum, but same is not the case with the temperature. The temperature is more in the tropical region, less in the polar region. In the polar region, the temperature is in minus. Okay, temperature is more in the tropical region, but not maximum in the equator. It is maximum at the tropics. It is maximum at the tropics. Why not maximum at the equator? Because in the equatorial region, there is everyday rainfall. Because of everyday rainfall, temperature decreases. So thickness is maximum at the equator, but temperature is maximum at the tropics. I hope you have understood. And here, this is where UPSC may ask, confuse the student with the question. Okay, so here if we take with respect to the different season, so when it is summer in the northern hemisphere, okay, summer in the northern hemisphere, this tropospheric atmosphere plus the heating would be like more in the northern hemisphere, less in the southern hemisphere. When it is summer in the southern hemisphere, it would be accordingly. So what did we study is in the troposphere, as altitude increases, temperature decreases. This decreases the temperature at the rate of 1 degree per 165 meter is adiabatic or normal lapse rate. Similarly, when the altitude decreases, so certainly the temperature will increase. Temperature will increase at the same rate, na? Yes or no? As the altitude decreases in the atmosphere only, not in the interior. In the atmosphere only, as the temperature, as the altitude decreases, temperature increases at the rate of 1 degree per 165 meter. Okay. So this vertical transfer of the heat is known as convection. Vertical transfer of heat is known as the convection. See, when the when the insolation is received on the surface of the atmosphere of the earth, the surface becomes hot enough, and this air which is in contact with the hot surface will be receiving some amount of heat. So there is a transfer of heat, yes or no? So this transfer of the heat is conduction. Okay, conduction. And so in the there is layer of the air above it, so there will be transfer of the heat and different layer, but at each of these layer the some amount of the heat will be lost, yes or no? So this transfer of the heat is convection. Okay, so when it is surface and the air, transfer of heat is conduction. When it is the same medium, okay, wherein the heat particle itself is moving, so it is convection. Okay, so you must remember this. As the height increases, temperature decreases, it causes atmospheric cooling. As the air descends down, temperature increases and it may heat up. Okay, when the transfer of the heat is vertical, convection. When the transfer of the heat is horizontal, it is advection. For example, hot air transferring horizontally. For example, loo, it is summer that is going on. You must have experienced a very high temperature these days. So this horizontal transfer of heat from one place to another place, that is advection. Okay. So what are the climatic phenomena in this region? So majority of the climatic phenomena, be it formation of clouds or the thunderstorms or anything, okay, formation of the lightning or the cloud burst, cyclone, all of these phenomena takes place in the troposphere. In other layer it does not happen. Then the majority of the wind patterns, that is trade wind, westerlies, polar, easterlies, also occur in this region. Okay, there is also the Indian monsoon, or the reversal of the wind is also in the same region. Okay, the transfer of the heat we have already studied, the latitudinal heat budget. In the tropical region, heat is high. Okay, in the polar region it is in deficit, so heat transfer takes place from the surplus to the deficit region. And this region, mid latitude region, where the heat transfer is taking place, this is the region which is very unstable. Okay, very unstable. Okay, so wherever there is some mechanism that is taking place because of differences, and wherever that mechanism happens, there is always instability. With respect to the water cycle also, water in all the three states, solid, medium, liquid, all the three states is found in the troposphere. With respect to the turbulence in the atmosphere, air transportation, if you have ever been in flight, you must have experienced turbulence in the flight. So why is that so? So when the air is rising, when the hot air is rising, and when the plane is flying above the hot air, so what will happen is this hot air will push or disturb the flight. Okay, so in order to avoid that, what is being done is, in the tropopause or lower stratosphere, above the cloud, the flight is flown. Okay, so because of that, what happens is, as the air rises upward, it will condense and it will form cloud, and beyond that air will not rise, and it can and the aeroplane will have a smooth flight. I hope you are understanding this. But as the altitude increases, temperature will decrease, no? So the passenger sitting inside must be feeling very cold. As the altitude increases, density decreases, so passenger inside will be feeling like breathlessness because oxygen will be less. And at the same time, as altitude increases, pressure will decrease. When the pressure will decrease, heart will beat more faster because there is no counter atmospheric pressure to suppress the heartbeat, so heartbeat will increase. Okay, so there is a lot of complexity associated with the flying above. Okay, so in order to avoid or minimize the risk, it is like fabricated in the form of a capsule, wherein the temperature, pressure and density inside the aeroplane is very well balanced. Next is stratosphere. So in the case of the stratosphere, we have seen that this is that layer where as the height increases, temperature also increases. How do the temperature increases? In the stratosphere, there is one layer that is known as the ozone layer. Okay, ozone layer is responsible for absorbing the UV radiation, and as the ozone layer absorbs the UV radiation, it fragments into oxygen molecule and oxygen. Okay, oxygen molecule and oxygen. And at the same time, release of the heat energy takes place. The heat which is stored in them will be released out, and it is because of this release of the heat energy, stratosphere will have the temperature in the increasing trend. Okay, but not very high. It will not continue, because above that will be mesosphere. Mesosphere is that region where there is no source of heating, so certainly the temperature will fall. The majority of the meteorite from the asteroid belt, some meteorite fall on the earth. Okay, and most of these meteorite they burn up in this mesosphere layer, thereby producing meteor shower. When it comes to thermosphere, in the thermosphere I have said that there are two layers, ionosphere and the exosphere. So ionosphere is that layer where ions are there, positive, negative ions, and the freely moving ions are there, and they act as a very strong reflecting mechanism for the radio waves released from the earth's surface, and this can be used in the radio communication also. Okay, high frequency short wavelength radio communication. Okay, so ionosphere, I have got these ions which is randomly just running, and because of the collision with each other, they release some heat energy. So ionosphere temperature would also be relatively on the higher side. Okay, let us do one or two questions related to this now. The question here, question number 1: the jet craft fly very easily and smoothly in the lower stratosphere. What could be the appropriate explanation? 1. There are no clouds of water vapor in the lower stratosphere. Yes, because if there is cloud in the lower stratosphere also, again jet craft will not have a smooth ride. Yes or no? It would have to go much above that. Statement 1 correct. Statement 2: there are no vertical winds in the lower stratosphere. Again, if there is vertical wind in the lower stratosphere, again it will create a bumpy ride. Yes or no? So again there is no vertical wind. So both statement is correct. This is the official answer given by the UPSC also, because most of the students are confused in this question. Answer is C. Official answer says C. Then statement 2. A layer in the earth atmosphere called ionosphere facilitate radio communication. Why? 1. Presence of the ozone. Ionosphere and ozone. Presence of ozone causes reflection radio waves? No. Presence of ions causes reflection radio waves. Wrong. Radio waves, the radio waves have very long wavelength. No, they are shorter wavelength. Okay, shorter wavelength. High frequency, short wavelengths. Okay, so this is also wrong. D is the answer. Next, thickness of the atmosphere is maximum over the equator. Yes, thickness is maximum over the equator. And what did we study? That temperature is not maximum at the equator. Temperature is maximum where? It is maximum at the tropics. Reason: high insulation and strong convection currents over the equator. Correct. Okay, I hope you are now getting comfortable with the questions, because it is very, very important that whatever you are studying, whatever, irrespective of which book, which material, okay, you are studying, if you are not solving questions, then you are actually not competing for the exam. Here, global distribution of temperature, as you've already done the analysis, there are many questions. So at equator, that is this latitude 0 degree, that is equator, at low latitude the temperature is relatively high but not maximum. Maximum it is at tropics. This is tropic, and as you proceed ahead, this is polar region. So as the latitude increases, temperature first increase and then it decreases. Maximum at tropics. Altitude, as the height increases, temperature again starts to decrease. Okay, then specific heat. Okay, specific heat is also one of the important factor why the temperature is different. So with respect to the specific heat or distance from that of the sea, see, specific heat is what? It is the amount of the heat required by an object to increase the temperature by 1 degree Celsius. Okay, it is the amount of the heat needed by an object to increase the temperature by 1 degree Celsius. So here you consider water, soil and rock. You consider it is a daytime or summertime. So which one of the three will be hottest? Certainly rock will be hottest, water will be the coolest one, and when it is winter, the same object will be coldest one, because an object, when it receives the heat very fast, okay, will also emit or radiate out the heat at the similar rate. The object which heats up slowly will also release the heat very slowly. Okay, so of the three, this will be the warmest one, this will be the coldest one. Let us put in terms of some values. This is hottest and this is coldest, this is coldest and this is warmest one. Okay, so can you see the temperature difference? The temperature difference, during the summer or the winter in the case of rocky area will be more. So rocky area or sandy area during summer will be very hot, during the winter will be very cold. For example, you take Delhi. Okay, on the other hand, you take those region which is near the sea, near big major water bodies. So during the summer not very hot, during winter not very cold, so moderate. Okay, moderating effect. Okay, so this is basically insular type of climate, no major change in the heat. Okay, and here in this case it is called as the continental type of the climatical condition. So as you move from the sea area towards the interior, continentality will increase. As you move from the interior towards the coastal area, insularity will be increasing. Okay, insularity. So you take, for example, Delhi and Mumbai. Mumbai would be having more of insular climate, Delhi will be having more of a continental climate. Or you compare on the same latitude, Mumbai and let us say Nagpur. So Nagpur in the interior, so continental climate, and Mumbai insular type of climate. You take the case of Bangalore and Bangalore. Bangalore would be having more of insular climate, and Bangalore will be having more of a continental type of climatical condition. Okay, so if you take in the case of thermal contrast is more in the continent as compared to the water body. Okay, thermal contrast is more in the high latitude as compared to the low latitude. Also thermal contrast is more in the winter than as compared to that of the summer. So this first point you must have already studied because of the specific heat. Other reasons are also related to the specific heat, but we'll see individually some more. Another factor that is responsible for variation in the temperature in different parts of the world is oceanic currents. Influence of this oceanic currents. See, oceanic water, surface of the water is relatively warm because of sunlight, and when the wind moves over the oceanic water body, it drags the oceanic water body in a particular direction. When it drags in a particular direction, so on one region it will be relatively warm and the other region of the ocean will be relatively cold, because the water will be moving upwards, upwelling of the ocean current will be taking place. So a thermal contrast on the surface of the ocean water can be observed. Okay, so this region which is under the influence of warm oceanic water will be having like a warm and moist type of climate, because evaporation and precipitation will be taking place. This region which is under the influence of cold oceanic currents will be having relatively cool and dry type of the climate. Okay, I hope you are understanding. Now these are some technical one, and a question last time question was asked here only. So if you take the case of you consider this is North America, South America, Atlantic Ocean, Europe and Africa, and the warm oceanic current is moving as a trade wind is moving, and it is piling up on the east coast of the North America, South America. So this east coast will be having relatively warm and moist climatical condition. Here the west coast of Europe and Africa, so in the low latitude region, will be having relatively cool and dry climatical conditions. Okay, then air mass. Warm air mass will be causing high temperature, cold air mass will be causing low temperature. Okay, in detail we will be doing air mass. Now with respect to the orientation of mountain, just try to understand this. Okay, consider a mountain, consider the mountain, and the sunlight is falling on one side of the mountain, so certainly temperature in this side of mountain will be higher, and temperature on this side of the mountain will be relatively colder. Yes or no? This will be more colder, this will be more warmer. So where will the human settlements prefer to live? So human settlement will prefer to live in this region because there will be vegetation also. Yes or no? And if the sunlight is there, then the farming or other activities is possible, right? And on the other hand, the shadow region, photosynthesis would be difficult, farming would be difficult. Okay, so here in this case, when the mountain is oriented in the north-south, in the north hemisphere, it is oriented in the east to west direction. So sunlight will be mostly associated towards the south of this mountain. North wala region will be in the shadow, and in the southern hemisphere, the south wala region will be in shadow and north wala region will be having the sunlight. So mountains play a very, very important role in distribution of the sunlight. You take for example Himalayas. So that the sunlight goes from the Tropic of Cancer to Tropic of Capricorn only. Perpendicular sunlight is only up to this region. So the sunlight Himalaya is very, very tall. So because of that, south of the Himalaya will be catching more of the sunlight. North of the Himalayas will be relatively cool, dry. Okay, so mountain range will be responsible for different would be responsible for distribution of the temperature. Okay, with respect to the vegetation, influence of vegetation, those regions having high vegetation will be having less temperature because vegetation will be absorbing the greenhouse gas, that is carbon dioxide, from the atmosphere and bringing down the temperature. So these are some important factor that causes variation in the temperature. Okay, and it is because of this vegetation only that those regions not having the sufficient amount of the vegetation will be having the relatively hotter summer. Okay, so those cities wherein vegetation is not there, plus concrete infrastructure, concrete road is there, and closely built up infrastructure, industries and the automobiles, all of these contribute to very high temperature as compared to the nearby rural region wherein the infrastructure is not like this, and there is good amount of vegetation also, so it leads to the formation of the urban heat island. Now from this year perspective, summer is very hot and you may expect question related to urban heat island, because in many parts of India extreme high temperature was noticed, and whenever these things are there in the news, UPSC is certainly going to ask question. A classic case study is the case study of Delhi. Delhi is frequently in the news for the pollution, for the urban heat island effect because of continentality, because of human factors like industrialization and stubble burning, which causes a pollution dome as well as the urban heat island effect. Pollution dome usually in the winter and urban heat island usually in the summer. Okay, so we have understood couple of factors that causes the temperature variation, and now we can solve some question. Question number 8 you can try. Question number 8, very important and a tough question. So here the question says, statement 1, the temperature contrast between the continent and ocean. So we know the temperature contrast between continent and ocean. Continent temperature contrast is more as compared to ocean, we know. But here it says during summer is greater during summer than in winter. Greater during summer than in winter. See, just to understand this, that it is winter. Okay, consider the same case. It is winter and it is the continent and the, yes, so it is during winter, the rock, let us say, what will be the lowest temperature of the rock? The lowest temperature of the rock would be of any object, let us say. The lowest temperature, let us say, would fall in minus, okay, not rock, but certainly the water bodies, the temperature will go in minus, yes or no? So the lowest up to what the temperature it can go, let us say it can go up to 50, 60, okay. In Siberia, it can go beyond minus 60 also, okay. And during the summer, the temperature in the similar region would be like 0, or it can go be 5 or 10 degrees Celsius. Okay, so so the coldest material in the colder region, let us say, water would be into minus few degrees Celsius. Okay, especially the surface would be in minus few, and the rock, the temperature would be like into minus few degrees Celsius, minus 5 or minus 10. Water will be like, or the atmospheric would be like minus 50 or minus 60 degree. So minus 60 degree or you take 10 degrees Celsius, so it will be a big range of 50 to 60 degrees Celsius. When it is summer may consider the same region, okay, same region and same water and the rock. The water maximum what degree water will be in the liquid form, okay, just beyond the 0 degree it will be in the liquid form, and the water temperature may go up to 25-26 degrees Celsius also, and during this rock area the temperature would be like 50 degree or 60 degree. So the difference in the temperature would be like 25 to 35 degrees Celsius difference will be there. So summer may difference in the temperature, okay, will be 25, 30, 35 degree. In winter, the difference in the temperature would be like 50 to 60 degrees Celsius. So the contrast during the winter is more. Thermal contrast during the winter is relatively more as compared to that of the summer. Statement 2. The specific heat of the water is more than that of the land surface. Yes, this is true. Specific heat of the water is more as compared to that of land surface. Land surface it can be rock, soil, sand, anything. It was a tough question, but it can be solved by logic. Question number 9. The annual range of temperature in the interior of the continent is high as compared to the coastal area. Yes, in the interior, in the rocky area, sandy area, the range of temperature is high. Yes, as compared to the coastal area, it is mainly the insular type of the climatical condition. So what is the reason for this? It is the specific heat, which is the thermal difference between the land and the water. The rest other is not the case. If you take question number 10, similar. Annual range of temperature is greater in the Pacific Ocean than that the Atlantic Ocean. See, Pacific Ocean is bigger than the Atlantic Ocean, and water body which is very, very big, very, very huge. So it will not become very hot or very cold, because huge amount of energy will be required to make it hot. Huge amount of energy will be needed to release to make it very cold. Okay. On the other hand, Atlantic Ocean is surrounded by North America, South America, Europe and Africa. So it is surrounded by continents. When the continent becomes hot, water will become hot. When the continent is cold, water will become cold. So thermal contrast in Atlantic Ocean is more, okay, as compared to that of Pacific Ocean. So range of temperature in Atlantic Ocean is more. Second, annual range of temperature is greater in the northern hemisphere than that in the southern hemisphere. North hemisphere have more of land, more of continents like North America, Europe, Asia, okay, and South hemisphere have South America and Africa as a major continent. And if you see in proportion of land, so North hemisphere have 40% land, 60% water. South hemisphere have 20% land, 80% water. So when the land is more, thermal contrast will be more. So thermal contrast is more in North hemisphere as compared to that of the southern hemisphere. Okay, so these are very very concept based questions. Very high chances any year it can be asked. Now the last question of this topic is, normally the temperature decreases with the increase in the height from the Earth's surface, because temperature decreases with the increase in the height. Atmosphere can be heated upwards only from the Earth's surface. Yes, it is because of the outgoing radiation. There is more moisture in the upper atmosphere. Wrong, there is less moisture. The air is less dense in the upper atmosphere. Yes, this is correct. Okay, the air is less dense in the upper atmosphere. So second statement is wrong. 1 and 3 is correct. Okay, let us proceed with another important topic, that is pressure belt. Now this is important. We can see some recent question also on the pressure belts. Now pressure belt is quite technical, and I hope you must have studied about different pressure belts of the world. And pressure belts not only help you to understand the important latitudes and the distribution of the high pressure or the low pressure, it also helps you to understand the wind pattern. Okay, atmospheric pressure. The formula for the atmospheric pressure is mgh, mass gravity into atmospheric thickness. Okay, if you consider on the peak of the mountain, the atmospheric thickness is relatively less, and here on the surface the atmospheric thickness is more. So pressure here will be more and pressure here will be less. Okay, so atmospheric pressure is usually measured in terms of millibar. As altitude increases, pressure decreases. So 1 millibar decreases after every 10 meter increase in the height. Normal atmospheric pressure is 1013.2 millibar. Okay, and wind always move from high pressure towards low pressure, high pressure towards low pressure. So for the movement of air, which is wind, a difference in the atmospheric pressure is must. Okay, now in the case of the atmospheric tricellular model, just try to understand, very very important diagram. Usually these diagrams are available in the form of pictures in the books or the internet. They do not have sufficient data or sufficient concept. So it is very much advisable that student must draw these big diagrams in one page and try to add as much of concept as possible, so that one page of understanding may fetch you many questions and many concepts may be clear. Consider sun is over the equator. Just try to understand this. Consider sun is over the equator. So when the sun is equator, this region will be hot. When this region is hot, air above that region, the heat transfer will take place, the air will be hot. When the air is hot, air will be rising upward. Yes or no? Convection, air will be rising upward, and atmospheric thickness will be relatively quite high. On the other hand, consider polar region. Polar region, the surface is cold enough because sunlight is not able to reach up to that region. When the surface is cold, air is not able to rise up. It is very very dense. Okay, surface is cold, air is also cold. So atmospheric thickness is very very less over here, right? So now when the air is rising upward, what will happen to the air? It will not just go and pile up here. No? Air is a fluid. Fluid needs a specific mechanism to circulate. It cannot just flow in one direction. It needs a loop. Okay, so when the air is rising upward, the temperature will decrease, condensation will start taking place, let us say precipitation happen, and after that it will descend down. It will become heavy and it will descend down. Okay, it will descend down. When it descends down, it again have two options. Here high pressure will be created. Okay, when the air is descending, do you remember when the air was rising upward, air was rising? So when the load, air is having mass, air has some mass, and this mass is over a certain area. So mass upon area, this pressure. When the mass is released, when the mass is going upward, pressure reduces. So it is that region having low pressure. And when the mass is descending down, okay, so pressure upon this region will keep on increasing. So this is that region having high pressure. Okay, so it will be high pressure here also, and it will be high pressure over here also, 30 degree north and 30 degree south. So equator pe low pressure belt and 30 degree north and south pe high pressure belt. This is subtropical region, this is equatorial region. When the air is descending downward, again it will be moving high pressure. No? So high pressure, so low pressure it will be going, so it will go this way also, it will be going this way also. Okay, both the region it will be going. And the wind from the polar region, which is relatively a cold, dense air, okay, it is already down because of the cold surface, and it is not rising upward, so it is creating high pressure here. So high pressure here also, high pressure here also, so wind from here also moves, wind from here also moves, and here somewhere it converges. Okay, it converges somewhere over here. So again, after the convergence, what will happen? The wind have to go up only. It cannot go inside the earth, no? So it goes up only. So again, a low pressure is created here. Same happens in the southern hemisphere. Okay, so this is a low pressure belt, which is that region, subpolar low pressure belt, and high pressure belt in the polar region. So likewise, different pressure belt is created: equatorial low pressure belt, subtropical high pressure belt, subpolar low pressure belt, and polar high pressure belt. Wind always move from high pressure towards low pressure. And likewise, this circulation of the atmosphere is created: 3 circulations in north, 3 in south. These are known as Hadley, Ferrel, and the polar cell. Okay, try to understand that those regions where the air is rising upward, the condensation will take place, precipitation happens. So precipitation happens in the low pressure belt. Similarly, in this region, air is rising upward, precipitation will happen, subpolar low pressure belt. When the air is sinking downward, high pressure will be taking place. High pressure may no precipitation, high pressure may no precipitation. This low pressure belt is also known as doldrum, windless condition, because entire air gets uplifted. So doldrum, windless condition. This subtropical high pressure belt is also known as horse latitude. Horse latitude. Okay, that is the story behind this name. Don't need to go into the story by the way. Let us take the same diagram and plot it on the earth. Everyone be over here. This is earth. These are important latitude: 0 degree, 30 degree, 60 and 90, 0, 30, 60 and 90. So 0 degree was low pressure belt, 30 was high pressure belt, 60 was low pressure belt, and 90 was high pressure belt. Wind is always moving from high pressure towards low pressure, high pressure towards low pressure. Okay, the wind is moving in this direction. Similarly, wind is moving from high pressure towards low pressure, right? High pressure towards low pressure. So from polar high pressure, subtropical high pressure, it is moving towards subpolar low pressure belt. Do you remember this concept? Coriolis force. I hope you remember that. So in north hemisphere, Coriolis force deflects the direction of fluids in the right side direction. Do you remember that? And also, do you remember that amount of deflection keep on increasing from equator towards pole? From equator towards pole, degree of deflection keeps on increasing. So in the north hemisphere, as this wind is coming from high pressure towards low pressure, it is not coming straight, it is getting deflected towards its right. Okay. Similarly, when the wind is moving from this high pressure belt toward this low pressure belt, it is not going straight, it is getting deflected towards its right. But now deflection is not just a little right, it is more right, because now the value is increasing. 0, 30, 60, the value is increasing. So deflection will be right, but more right. Again, when it is coming from this high pressure belt toward this low pressure belt, again wind is not coming straight. Wind is deflecting towards its right. Okay, with more degree of deflection. Okay, so these are important winds, very important wind. This wind is known as trade winds. Trade wind is there in north and south hemisphere both. Northeast trade wind, southeast trade wind. This wind here, this one is known as westerly. Westerly is there in north hemisphere and south hemisphere both. And polar easterly. Polar easterly is there in the north hemisphere and the south hemisphere both. I hope you have understood this tricellular model of atmospheric circulation. Okay, and the same was, we saw the surface wind. This one, the lower one, and there are upper winds also. We just saw the lower winds. So these lower winds are the planetary winds, also known as primary winds, also known as prevailing winds. We just saw the lower one. The upper one would be like explained in the form of the jet streams. Okay, so pressure belt we have understood. Okay, the pressure belt, because of the heat, or the thermal, is because of the high temperature or low temperature, and these are equatorial low pressure belt and polar high pressure. Non-thermal or adiabatic is subtropical and subpolar. Isobars are the line joining the places having similar pressure. Isotherm is the line joining the places having similar temperature. Okay, and these isobars and isotherms are not constant. These isotherms keeps on varying from season to season. Consider, for example, in January it is northern hemisphere, and northern hemisphere it is winter. Okay, so northern hemisphere it is winter, so mainly winter is like less of heating, so more of high pressure region in the continent you will see. Okay, and low pressure in the water, and the reverse happen in the southern hemisphere. Okay, so there are several factors. Wind, before proceeding ahead with the wind in detail, wind is what? Wind is does the horizontal movement of air. And what causes this movement of air? It is the difference in the pressure. When the pressure is same, wind will not move. Okay, so some factors are there. That is pressure gradient force that will initiate the movement of the wind. There is frictional force. Friction is because of, let us say, vegetation or settlements, human settlements, okay, or rough surface or mountains, friction. And Coriolis force. Coriolis force is the force which deflects the direction of the fluid. Okay, so it either changes towards the left direction in south hemisphere, right direction toward the northern hemisphere. Okay, these pattern of the planetary winds, that is the trade winds, westerlies and the polar easterlies, they depend upon the latitudinal variations in atmospheric heating, pressure belts, migration of pressure belts, distribution of continents and ocean, and rotation of the earth. So that this is what just we have understood in the form of three important factors: pressure gradient force, Coriolis force, then even the gravitational force and the frictional force. Okay, wind now. So wind is what? Air in motion, horizontal motion, that is wind. When it is moving vertically upward, it is called as air current. It is called as current. Horizontal, wind. Vertical movement of heat, convection. Horizontal movement of heat, advection. I hope you are understanding this. And the factors is pressure gradient. More the difference. For example, here in the case of these 2 points, pressure difference is 50, so wind speed would be relatively slower. Here the pressure difference is much more, so wind speed will be relatively faster. Coriolis force, change the direction. Gravitational force, gravity pulls everything towards itself down. Frictional force. So all of these collectively act upon the wind and thereby affects the direction. Now there are basically three types of wind: primary, secondary and tertiary. Primary winds, or also known as a permanent wind, also known as prevailing wind or the planetary wind, are basically doldrums, that is, we just see the vertical upward movement of the air at the equatorial region. Trade winds, we saw northeast trade wind, southeast trade wind, north hemisphere, south hemisphere, westerly, polar easterlies. Secondary winds is also accordingly there. Sea and land breeze, mountain and valley breeze, and monsoon wind. And last is the tertiary local winds. Local winds can be either hot and dry or cold and dry. Primary winds, we just saw that the doldrums, where does it blows? It blows at the equator, vertical movement of the air, windless condition. Trade wind we saw in the north and the southern hemisphere. So and westerlies in the north and south hemisphere both. Okay, so here in this case of understanding the trade winds play a very, very important role in terms of movement of the oceanic water. Okay, the trade winds blows in the northeast to southwest direction in north hemisphere, and southeast to northwest direction in the southern hemisphere. Thereby it influences the weather of a local region. Okay, it also is responsible for bringing the precipitation in the case of India. Okay, westerlies in the northern hemisphere, southern hemisphere, both it is there, but in south hemisphere it is more stronger. It is very, very strong. So this strength is why, this strength is because south hemisphere have 20% of continent and 80% of the ocean. And over the ocean, friction is less, speed is very, very fast. Okay, so speed is very, very fast. So in different latitudes between 30 to 60 degrees south latitude, on 40, 50 and 60 degree latitude, it causes different noise. Thereby it is being given different names: roaring 40s, furious 50s and shrieking 60s. Okay, then polar easterlies brings very, very cold air from the polar region towards 60 degree north latitude as well as 60 degree south latitude. Secondary winds are very, very important. Okay, they influence the local climatical condition. So secondary winds over here, just try to understand that it is sea breeze, land breeze. Okay, so sea breeze. So during the daytime, during the summertime, when the sunlight is available, so sunlight will be hitting land also as well as the water also, but land will become more hotter because specific heat is less, specific heat is high, so it will be relatively colder. So when the land is hot, the air above that land will be hot enough and air will be rising upward, so low pressure will be created over here. And over here in this region, sea water body region, it will be relatively cold, so air will sink down and high pressure will be created over here. So there is a difference in the pressure that is created, high pressure and low pressure. So wind is going to move from high pressure towards low pressure, that is sea to land. So the name sea breeze. So during daytime, during summertime, sea breeze blows, brings cool air from sea towards land. Very useful also. Then during the night time, the phenomena gets reversed. Land, which was very hot during the daytime, will become cold at the night time, creating high pressure. Sea, which was cool during the daytime, will become warm at the night time. Okay, thereby creating low pressure. Again, wind is going to move from high pressure towards low pressure, that is from land to sea, thereby creating land breeze. Okay, so in winter, land breeze. Okay, then a very, very important set of secondary wind, that is mountain and the valley breeze. So during the daytime, what happens is the mountainous region will be having low pressure because of low atmospheric thickness, and the valley will be having high atmospheric thickness, so high pressure. So during the daytime, wind is going to move from valley towards mountain, so by valley breeze. And at the night time, what happens is, so nighttime, the loss of heat will be more from here because atmosphere is less thick, heat lost will be faster, it will become very cold, mountain peak will become very cold and high pressure will be developed. Loss of heat, since atmospheric thickness is more, loss of heat will be relatively slower, so it will be remaining relatively warm, so it will become low pressure. Okay, so what will happen is during the night time, wind is going to blow from mountain towards valley, so mountain breeze. Okay, so this plays a useful role at some places and it becomes very difficult at some other. For example, in the case of Mumbai, if you take Mumbai, so it is located along the coast of the Arabian Sea. Okay, so during the daytime, what happens is sea breeze blows, and on the other side of the Mumbai is the Western Ghat. So during the daytime, valley breeze also continues. Okay, and at the night time, the mountain breeze blows. Okay, and at the same time, night time, land breeze is also blowing. So the pollution, air pollution that is created, okay, keeps getting filtered. The air pollution that is created keeps getting filtered. Okay, so in that case, the atmosphere of the Mumbai remains relatively cleaner as compared to that of Delhi, because there is no mechanism, natural mechanism in the case of Delhi. Monsoon is also a secondary wind. In some books, it is also written as a tertiary wind, also known as a local wind. Okay, so secondary wind is the one which comes in one time and then goes in the other. So it is periodic coming and periodic going. So sea breeze, land breeze, mountain breeze, valley breeze. Monsoon is also periodic wind. It comes in one season, it goes in another season. So in summer, just understand this, Tibet is very, very hot. Okay, the peninsula, India also becomes very hot. So air rises upward from the hotter region, low pressure is created. And at the same time, the southern hemisphere is winter, north hemisphere summer. So southern hemisphere winter, water is colder, so high pressure, so wind is moving from high pressure towards that of the low pressure region. Okay, so when it is moving from southern hemisphere, it is getting tilted towards the left hand side because of Coriolis force. Equator pe no Coriolis force is acting, and in the north hemisphere get deflected towards the right hand side. Okay, Coriolis force. Thereby it will cover, you know, the different parts of the India in different time interval. Okay, and the same phenomena will get reversed during the winter time. Tibet is relatively cooler, the Indian Peninsula region also is cooler, so it will form high pressure region, and it is summer in the southern hemisphere, so it will be relatively warm and low pressure. In southern hemisphere, wind is going to move from high pressure towards low pressure. In the north hemisphere, again Coriolis force will cause it deflected towards the right, then equator pe no deflection, and southern hemisphere mein left hand side ka deflection. Okay, so in this way, different secondary wind is going to blow. The last in the set of this wind is the local winds. Local winds, also known as the tertiary winds, are basically two types: hot and cold. Hot, usually the one which is dry, okay, is useful at some place, and it is very difficult. It creates a difficult scenario at some other. So desert, in the desert region during the summer, very hot local wind blows. For example, Lu in the case of Thar desert in the case of India, and in the case of the leeward side of the mountain also, hot and dry local wind is created. For example, Chinook in the case of the USA. So Chinook, you consider USA. This is North America. I have just drawn the west part of the North America. A Rocky Mountain range, you can see Rocky Mountain range. So this local wind known as the Chinook that blows. So Chinook is what? It is a hot and dry local wind. So when the Chinook blows over this prairie grasslands, so it melts the snow of this grassland, thereby the grassland is free from snow. And because of that, what happens is, the vegetation, cultivation of rabi crops is very, very useful. Okay, cultivation rabi crops is very, very useful. See, when consider the windward side. So consider this is mountain, and the rain is moving from sea towards that of the coastal area, so windward side. So this windward side will be receiving the precipitation because moisture is being brought upon, and when the precipitation have happened, so the moist air will become dry air. Yes or no? The moist air will become dry air, and the moisture, it is holding moisture, and it is holding moisture because of heat. And since there is heat, so it will be the molecular spaces will be more. Molecular spaces is more, so density is less. Density is less, so it is rising above. Once again, when our air is hot, the molecular space will be more, and it will be holding moisture. Okay, so the moist air will be lighter, and it will be rising upward. When the moisture is gone, so molecular spaces reduces, the air become dense, and the dense air will try to sink down. The dense air will try to sink down. When the dense air is trying to sink down, okay, it is going to exert pressure upon those leeward region, and pressure in that region will increase. With the increasing pressure, temperature in that region will also increase. This is very important. Okay, many of the students feel that moist air is heavy because it is having water. Dry air is lighter because it is having no water. So don't go by that logic. That logic is wrong. Moist air is lighter, dry air is denser. Okay, same happens everywhere, same happens. So here, this is what I have tried to explain, that Chinook, which blows on the leeward side of the Rocky Mountain, it melts away the snow, and thereby it is also known as a snow eater, and thereby this region remains free from the snow. Cold and dry local winds. So cold regions are polar regions, so in that region blizzard, which is cold wind, blows. Also in the low latitude region, okay, at the high altitude, there is some cold wind blowing, that is Shitlahari. Okay, Shitlahari in the case of India. So you can take some of the examples of the local winds. Some of the examples of the local winds is already being asked by UPSC. Here in this case, see the Chinook local wind, northeaster blizzard, Norte, Pampero. Similarly, in the case of the Africa, Sirocco, Khamshin, Harmattan. Harmattan was asked by UPSC. Then Habubberg. In the case of Europe, some important like Fohn, very very important, again asked by UPSC. Mistral, Helm, Bora, okay, Levant, very important. Then in the case of India, they haven't given any information as such, but in the India, from Thar Desert during summer, Lu is generated, and during the winter time, Shitlahari. So these are two local winds of India. Okay, so here you can try this question, matching the list. Here the question is Fohn. Okay, we just saw that Fohn is in the Alps. Okay, then Zonda we haven't seen, but Zonda is here. Zonda is in South America. Okay, South America. So Zonda is in South America, and South America, the only South American country is Argentina. So you can go with this, and just by this you can understand that the 1 is Delhi and 4 is A. So that is the only option that is left out. B is the answer. Here the question is with respect to that of the Harmattan. So consider the following statement. Statement 2, just focus on statement 2. Harmattan is a dusty land wind of the East African coast, and Harmattan is blowing on the west, not on the east, West African coast. Okay, statement 2 is wrong. Okay, the rest of the other also needs to be discussed. We'll focus on the jet stream now. Or before that, some question we can try to solve. Question number 14, very simple. Either side of two belts over the ocean at about 30 to 35 degree north and south latitude is known as horse latitude. So 0 degree is known as equatorial low pressure belt, doldrum. 30 degree to 35 degree north is subtropical high pressure belt, horse latitude. 30 to 35 degree south, subtropical high pressure belt, again horse latitude. And second statement, horse latitude or low pressure belt? No, they are high pressure belt. Next question. 60 to 65 degree latitude in both the hemisphere have low pressure belt instead of high pressure belt. This is correct. This is known as subpolar low pressure belt. And reason, the low pressure areas are permanent over the ocean rather than on the land. It is incorrect because pressure belts are the pressure areas are directly proportional to that of the temperature. When the temperature is more, pressure is less. When the temperature is less, pressure is more. So this is wrong. Wind. Okay, it says in the tropical zone, western section of the ocean are warmer than the eastern section owing to the influence of trade wind. So you consider the western section of the ocean is warmer because of this trade wind. Trade wind carries the surface water towards the west, and thereby the western section of the ocean is warmer and the eastern section is relatively cooler. This is what we had studied. And in the temperate zone, westerlies make so in the temperate zone the reverse will happen. Westerlies will take that water from the west section of the ocean towards east and make the eastern section warmer. So westerly make the eastern section of the ocean warmer. True. Next, the wind which blows 30 degree north and 60 degree south latitude. This is a trap now. It is 30 degree north and 60 degree if it is north, or 30 south and 60 south, then it is correct. So the wind which blows between 30 north and 60 south latitude throughout the year is known as westerlies. This is wrong. 30 north to 60 north, 30 south to 60 south. Okay, the moist air that causes winter rain in the northwestern region of the India part of westerly. This is correct. Okay, westerly in south hemisphere are stronger and persistent than north hemisphere. True, because south hemisphere have more of water bodies and less of land. So southern hemisphere has less land mass as compared to the northern hemisphere. Yes, more of ocean. Coriolis force is higher in southern hemisphere. No, this is wrong. Okay, and very simple question: what causes the wind to deflect towards left in the southern hemisphere? It is a Coriolis force, and Coriolis force is because of this rotation of the earth, right? So these questions I hope you are able to understand. We'll see the jet streams now. So jet streams now. So jet streams are the one which is not blowing on the surface. These are the winds which is very, very fast blowing wind in the upper troposphere. So we have already studied this model of atmospheric circulation. So just understand that here in this region, in this Hadley cell, when the wind descends down over here, so a region is created wherein the wind, there is a horizontal blowing wind which is very, very fast blowing wind blows in this region, okay, which is irrespective of these. Here similarly again, when the wind is rising upward, again a certain region is created wherein very, very fast blowing wind, that is the jet stream, is created over here. So jet streams is there in the north hemisphere also as well as in the southern hemisphere also. These jet streams, which is subtropical jet stream because of the region, and the polar jet stream because of this respective region, these are permanent jet streams. Likewise, there are temporary jet streams also. These temporary jet streams play a very, very important role in the Indian monsoon. So just understand, this is the wind which is blowing in the upper layer. Okay, I have drawn this diagram for the upper blowing wind. So we have a jet stream blowing in the northern hemisphere, that is subtropical jet streams and the polar jet streams. Similarly, in the southern hemisphere we have jet streams, that is the subtropical jet stream and the polar jet streams. They play a very important role. So jet stream play an important role, especially in the case of the India. If we take it play a very important role in influencing the monsoon. More on this will deal in the Indian monsoon, because a more understanding is needed. Here it is sufficient enough to understand that jet streams are very fast flowing winds in the upper troposphere. There are two types, permanent and temporary. Permanent is polar subtropical jet streams and the polar, and temporary one is the tropical easterly, also known as the African easterly jet stream and the Somali jet streams. Okay, here if you do only statement 1, not the 2 or 3, because for 2 and 3 we need understanding of cyclone. It says, consider the following statement 1, jet streams occur in northern hemisphere only. So this is wrong. It happens in the north as well as southern hemisphere. So statement 1 is wrong. Okay, the rest we'll do as we proceed ahead with the other topic like cyclone. Air mass. So air mass is basically that homogeneous air which is relatively having similar temperature, density, okay, and pressure horizontally. The horizontal variation is and vertical variation also is relatively very less. How did it gets this homogeneity? This is because of the source region. For example, desert can be a region wherein the huge air mass is resting. If the desert is hot, it will derive that characteristic, that air will also become hot. If let us say glacier region, when the air is resting over a glacier region, so glacier region would be quite cold, so air mass would also become cold. When it is resting over the ocean surface, so ocean surface would be giving a lot of moisture to the air mass, so it will be moist air mass. So likewise, the air mass derive its characteristic from different sources, and accordingly air mass can be warm, a source region for the air mass can be warm tropical or subtropical ocean region, or the subtropical desert region, or it can be high latitude oceans, cold oceans. It can be snow covered mountain, or it can be permanently covered Arctic and Antarctic. And likewise, there are 5 air mass. The air mass in simple words can be warm or cold, and over here in terms of the sources region, it can be maritime tropical, continental tropical, maritime polar, continental polar, or continental Arctic. There is no continental Antarctic. The warm and cold air mass, they are contrasting in nature, and when they meet, they form a different climatical condition. So cold air mass would be responsible for decreasing the temperature. Warm air mass will be responsible for increasing the temperature, and when both of them meets, the zone at which they are meeting is known as front. Frontogenesis is the process of formation of the front, that is meeting of two contrasting air mass, and frontolysis is breaking of the fronts basically. Okay, so front formation takes place. So in the case you consider the cold air mass and the warm air mass. Cold air mass and the warm air mass. Warm air mass is stationary. Okay, cold air mass is moving. Cold air mass is moving, and it is causing the warm air mass to be thrown upwards. Warm air mass is moving. This is stationary. It is causing warm air mass to be thrown upwards. So when the warm air mass is rising upwards, okay, so vertical movement of the air will be taking place, condensation will be happening, and cloud formation will take place. And cold air mass is also creating obstruction from one side, so the movement is only vertical, and vertical tower of the cloud, that is cumulonimbus cloud, will be formed. This region will be associated with very heavy rainfall. So cold front, so this region is this front, and cold front because cold air mass is moving. So this region or the cold front is associated with the very heavy rainfall. On the other hand, when the air mass is relatively warm enough, okay, and there is a cold air mass also. When the warm air mass is moving, this is taking the initial movement. Cold air mass is at its place. Warm is suppressing the cold air mass. Warm is suppressing the cold air mass and then moving along its slope. So in that case, slope will be relatively gentle. It will be relatively gentle. So in both the cases, be it cold air mass or warm air mass, warm will only rise up because warm is relatively lighter, less denser. So as it is rising upward, it will not form a vertical tower of the cloud. Cloud formation will be taking place. Okay, stratus, nimbostratus, altostratus. Okay, then cirrus. All of these cloud formation will be taking place, and along this front, precipitation will be taking. Okay. Precipitation will be not so strong as compared to the cold air mass. Okay, so likewise when this when both cold air mass and warm air mass, when both is moving and both is relatively like equal in terms of the potential or the strength, and none of it is able to suppress the other one. So here in this case, a stationary front will be created where there will be like just a cloudy sky but no precipitation as such. On the other hand, when there is already a warm front, initially a warm front was there, and the cold air mass is overtaking this warm front, thereby completely causing the warm air mass to rise, completely get uplifted. So when the complete upliftment take place over here, the snowfall will take place. So just take it this way. So there is already a warm front, and warm front is replaced by the colder front. Okay, replaced by the colder front, and the warm air mass is completely being thrown upward. So here there will be a roll of two cold air mass and one warm air mass. So when it is rising upward, so rising at a greater altitude, the rainfall will be converted into snowfall. So occluded front is that region where it will be associated with the snowfall. Okay, proceeding ahead now. So it is the water or the snowfall or the ice crystals or the hailstorms, all of these are associated with the vertical movement of the air. Okay, and this vertical movement, the water in the atmosphere, which is the humidity, is directly proportional to that of the heating. Okay, more the temperature, more is the ability of the air to hold the moisture. Condensation are of various types. Okay, condensation, when the surface any surface you take where it is very, very cold enough but not into minus, when it is cold enough, the moisture from the air will get condensed over the surface, leading to the formation of dew. Okay, factor responsible for the formation of the dew drop is that the dew point should be above the freezing point. It means it should not be in minus, else instead of dew it is going to be frost. Okay, it is going to be frost. And the condition over here is clear sky, because if the sky is cloudy, what will happen is the air will be the heat will be reflected back, temperature will increase, and when the temperature increase, then dew drop will not be formed. Then calm air should be there, high and relative high high humidity should be there. Okay, long and cold winter night, dew point should be above freezing point. This was a UPSC question in 2019. Similarly, with respect to the frost, the condition is relatively similar, but the dew point should be below the freezing point. It means it is something associated with the ice. So again, clear sky, calm air, high humidity, long and cold winter night, dew point should be at or below the freezing point. Frost formation will be taking place. UPSC have asked question on dew drops. It may ask question on the frost also. What is fog and mist? So it is nothing but the moisture in the atmosphere. In the case of mist, moisture is more as compared to that of the fog. Snowfall and sleet, what is the difference? In the case of the snowfall, it takes place at the 0 degree. Okay, and in the case of this sleet, it is the sleet formation takes place at above the freezing point. Oh, that is below the freezing point in terms of minus. Hailstorms, for the formation of the whole hailstorms. So similar phenomena like that of the rainfall formation, but it is formed at a relatively greater altitude where the temperature turns into minus. So it is going to form, instead of the raindrop, it is going to freeze and form the ice crystal. Okay, so these latent heat and all are important. It is advisable that you should be studying them. Clouds, very, very important. With respect to that of the cloud, UPSC have asked question couple of times, so it is advisable that students should do. Clouds, so clouds at different altitude, it is important. At the lowermost altitude is stratocumulus, stratonimbus, which is about 6,500 above ground level. So these are the clouds which is formed at 2 to 4 kilometer at the height only. Above that, the altocumulus and the altostratus cloud, just look into the how do they appear, and much above that is the high clouds, which is cirrus, cirrocumulus and the cirrostratus. So most of the rain bearing clouds are the clouds which is below. Okay, the rain do not fall from such a great height. Okay, cumulus cloud, which is the rain bearing cloud, is mostly in the lower altitude. Cumulonimbus cloud is a vertical tower of the cloud. It is very, very dangerous. It is associated with the thunder, lightning, okay, and very heavy storms. Okay, what are the impact of the clouds? So apart from just rain, it plays a very, very important role in deciding the weather phenomena. So just try to understand this. Cloudy nights are relatively warmer because what happens is during the night time, the terrestrial radiation which is going into the space is being blocked by the clouds, and the radiation gets reflected back into the atmosphere and the temperature increases. So cloudy nights become bit warmer. You must have experienced this when it is cloud, the warming takes place, right? And cloudy nights will also prevent formation of dewdrops. High cloud versus low cloud. See, we have already studied that clouds are responsible for reflecting of the sunlight. Clouds are responsible for the reflection of the sunlight. So high clouds or the low clouds, both are responsible for reflection. We have also studied that clouds prevent the radiation from going into the space and may reflect it back toward the atmosphere. But the high clouds and low clouds have different role. The cloud which is relatively much lower or close to that of the ground, so a much larger area will be covered. Okay, it will be covering. So what will happen is it is going to reflect more of the sunlight. More of the sunlight will be reflected. Albedo will be more. When albedo is more, albedo causes cooling effect. Yes or no? When the albedo is more, means much of the sunlight was not able to reach the surface. It means less radiation, less terrestrial radiation is going to get emitted, and less of the terrestrial radiation is going to get reflected back. Yes or no? So this reflection causes heating, albedo causes cooling. Albedo is more and this reflection is relatively less. So overall, low cloud will cause more of cooling effect. Similarly over here, now try to understand high clouds. Now high clouds is much above. So most of the sunlight is going to enter into this region from side. Yes or no? Most of the clouds, high clouds, are scattered also, and most of the radiation is going to enter from side, and it is going to cause warming. So less of the albedo will be there, more of the heating of the surface, more radiation and more reflection back. Yes or no? So because of reflection, heating will be there, because of albedo, cooling will be there, but this is going to be more dominant, albedo is going to be less. So high cloud will be responsible for higher temperature. Low clouds will be responsible for lower temperature. That is, low cloud is responsible for cooling. Okay, cooling effect. Okay, rainfall. So as one moves away from the coast, the amount of the rainfall precipitation starts to decrease. UPSC prelims question 3 times. Okay, but in the Indian monsoon, as altitude increases, temperature decreases, and the amount of precipitation also start to decrease. When the rainfall is in the same region where the convection is taking place, condensation, precipitation. This type of rainfall where the convection, wherever the convection have taken place, precipitation have taken place at the same region, so it is convectional rainfall. So equatorial region, convectional rainfall takes place. And in India during the summer, extreme summer, May usually, the coastal regions of the India will have light shower of the rainfall, especially because of very hot summer. Okay, convection and then precipitation. So these are named differently: Kal Baisakhi, mango shower, cherry blossom, okay, and sandstorm. In the case of mountain, when it act as a barrier to that of the incoming moist air, so one side of the mountain will be having rainfall, so this is the windward region. The other side will be having relatively a drier region. Okay, so this type of rainfall, because of mountain obstruction, is orographic rainfall. For example, monsoon. We have already seen the pattern of the monsoon, and the amount of precipitation along the western side of the coast, Western Ghat, will be high. Eastern side of Western Ghat, the amount of rainfall keeps decreasing. Similarly, Meghalaya Plateau, the windward side of this Meghalayan Plateau, high rainfall. The leeward side would be relatively lesser rainfall. Okay. So this is orographic in nature. Okay, and the one more rainfall is the frontal rainfall. So frontal rainfall we have already seen. Cold front, very heavy rainfall, and warm front, relatively lighter rainfall. So rainfall is because of all these 3 reasons. Thunderstorms. So thunderstorms is created because of formation of the cumulonimbus cloud. Okay, thunderstorms can be created because of this orographic, that is mountain obstruction, not allowing the wind to disperse after going upwards. So this type of thunderstorm is this orographic, and this because of this cold front when the thunderstorm is created, so it is the frontal thunderstorm. Lightning is because lightning is the static charge which is released because of the differential charges between the clouds and between cloud and the earth, because earth is positively charged. Okay, so static release of this charge is the lightning. Cloudburst phenomena, again it is a technical phenomena associated with this term when the amount of rainfall is more than 100 millimeter and it is covering a region of 10 to 20 square kilometer, means smaller region, in less than 1 hour. So in less than 1 hour, when the rainfall is more than 100 millimeter, covering a region of 10 to 20 square kilometer area, so this condition is called as cloudburst. Cloudburst causes flood, they're known as flash flood or torrential flood. Hailstorms, we have just seen hails, so I'm not repeating this thing. Cyclones now. Very, very important. So cyclone is what? It is a low pressure atmospheric system with a very low pressure at the center. So in the case of the cyclone, it is a low pressure system. So wind from the adjacent high pressure region comes and it rises upward. So it rises upward. At the same time, it's not just wind coming up and going upward, it is spiraling also, it is coiling also. So just try to understand in this case. So this is a low pressure region, and you consider the high pressure adjacent region. So in this case, low pressure region, high pressure adjacent region, so wind is moving from high pressure towards low pressure. But if you consider the north hemisphere, the wind is going to get deflected towards right hand side, so it is going to approach from here to here, but from right, and thereby it will form an anti-clockwise direction. Similarly, in the southern hemisphere, wind is going to move from high pressure to low towards low, but from left because of Coriolis force. So cyclone in the southern hemisphere will be clockwise in direction. Okay, so So in that sense, it is going to approach the low pressure region, and then it is going to coil because of the Coriolis force in north hemisphere towards anti-clockwise, south hemisphere towards clockwise, and likewise it is going to rise up. So this side, okay, this side of the cyclone is known as eye wall. The center of the cyclone is known as eye. Eye is basically a very, very low pressure point. Not all cyclone will have eye. Yes. Okay. The air rises along the side. Okay. So along the side, the cloud formation will be there. And those air which is in between, this region will be relatively calm zone, silent zone. So the air is going to descend in between. Okay. And along the side, the air is going to rise. So if you see the same diagram here, this is the cyclone, and the most of this cloud formation is along the side. So side it is going to rain heavily, not in the center. Cyclones can be 150 to 250 kilometer in terms of diameter, and 150 to 250 in terms of speed, 150 kilometer to 250 kilometer per hour. Okay. In the case of the cyclone in the Arabian Sea and the Bay of Bengal, the cyclone is as big as 600 to 1200 kilometer in terms of diameter. Cyclones are of two types, tropical and temperate. Tropical cyclone, factors responsible for tropical cyclone: large sea surface area with a very high temperature of 27 degrees Celsius. These are the conditions mentioned in the NCERT also, and question asked by UPSC also. It also needs Coriolis force for twisting effect. Okay. Small variation in vertical wind speed. Vertical wind speed, the variation must be relatively small, else the coiling will not take place. Low pressure should be already existing, and upper divergence above the sea level. When it goes, and it should diverge. Okay, it should not go and get concentrated upwards. Okay. So usually some cyclone is something which is rotating mechanism. For the rotation, there is an axis of rotation. Okay, something rotating forms an axis. So axis of rotation, when it is vertical, so this rotating mechanism will be strong enough. When it gets tilted because of some reason, let us say there is a very fast blowing wind and it is pushing this, so it will be pushed, okay, and it will fall, it will collapse. So this vertical wind shear, it is called as vertical wind shear, that should not be there. Okay. So again, the same anatomy of the cyclone: eye of the cyclone, the eye wall, and the cloud formation along the side. In between, the air is the calm zone. Because of that, air will be subsiding downwards. Okay. Usually the cyclones are named. This naming of the cyclone is because of the disaster mitigation mechanism. Cyclones in the tropical region and cyclone in the temperate region, we'll see. In the trade winds, we have seen. This is the trade wind. This is 0 degree, 30 degree north, Tropic of Cancer. Okay, 0 degree, 30 degree south, Tropic of Capricorn. The trade wind blows in this order. Okay, and the cyclone also takes place along the warm oceanic region. So the trade wind is going to carry this cyclone from east towards that of the west. East towards the west of the ocean. And continent ka, this is west, this is east. So continent ka east is getting hit by the cyclone. Okay, continent east is getting hit by the cyclone because trade wind is bringing the cyclone from ocean towards the coastal area. Okay, so tropical cyclone hits the east coast of the continent. Tropical cyclone hits the east coast of the continent. When you come to temperate cyclone, so westerlies is blowing in this region. Westerly is blowing from west towards east. So the the temperate cyclone will be carried towards that of the east. And when it is formed in the ocean, then it is going to hit the west coast of the ocean. So tropical cyclone is hitting the east coast of the continent, and temperate cyclone is hitting the west coast of the continent. I hope these things are understood. Okay. In the case of India, India is a tropical region. So the trade wind is going to bring this cyclone and hit the India eastern coast. Okay, mainly in the Bay of Bengal region. Okay, and here in the Arabian Sea, cyclone is again being carried away, and by the trade winds hitting the coast of the Somalia and Yemen. But at times when the westerly is strong, the same cyclone is being diverted back towards India, hitting the Gujarat and the northern part of the Maharashtra. Okay, so it depends which one of the two is relatively stronger. The trade wind is stronger, the westerly is stronger. So accordingly, the cyclone will take a different path. Okay, so cyclone path, at times becomes very, very unpredictable. Okay, so naming of the cyclone for that purpose is done, so that cyclone information related to the cyclone can be spread, and this will help in the faster mitigation. Okay, so intertropical convergence zone are those regions in the tropical regions when the two trade winds are converging. That zone is tropical zone, and this is because of the relative position of the sun. When the sun is at the equator, intertropical convergence zone, that is these two winds will converge at the equator. When the sun is in the northern hemisphere, the two winds will be converging here at the tropic of the Cancer or at the tropic of the Capricorn. So this zone is in accordance with that of motion of the sun. Temperate cyclone, also known as the frontal cyclone, also known as the extratropical cyclone, is formed at the fronts. So the name frontal cyclone. So how this frontal cyclone is formed? See, just try to understand, for a cyclone formation, what are the two important factors needed? One important factor is low pressure and Coriolis force. Second factor is Coriolis force. So for the low pressure, see, just try to understand, when you heat the water, it becomes water vapor, and when you remove the heat from the water vapor, it becomes water again. Yes or no? So in simple words, when the water vapor is becoming water again, heat is released. Water vapor after precipitation becomes water again, heat is released. This heat is called as a sensible heat. This heat is going to increase the temperature, and this temperature is going to reduce the pressure. It is going to reduce the pressure. So just try to understand that at the fronts, the rainfall happens, especially the cold fronts, warm fronts, the rainfall happens, and they are going to release a sensible heat. Also try to understand that this is equator, so equatorial low pressure belt. This is subtropical high pressure belt, and this is subpolar low pressure belt. So already there is a low pressure. Plus frontal rainfall, so further drop in the pressure takes place, and because of that, what happens is cyclone is generated. Coriolis force is already strong because it is the high latitude region, so Coriolis force is already strong, and because of this, tropical cyclone, temperate cyclone is formed, and temperate cyclone is relatively more dangerous. Okay, and it covers relatively more area as compared to that of the temperate cyclone. Okay, this is what I have drawn. So it is a subpolar low pressure belt, wherein the westerlies and the easterlies, they will be merging over here, and also the front formations and the very intense cyclone will be taking place. Temperate cyclone, tropical cyclone, we had already seen it hit the east coast of the India, and here in the Arabian Sea it will hit the west coast of the India in case westerly is strong enough. And how about temperate cyclone hitting the India? The temperate cyclone in the India comes from this Mediterranean Sea, and the temperate cyclone do not reach up to India, but the influence of temperate cyclone in the form of rainfall, snowfall, that reaches the India in the month of January, February. Okay, this is the western disturbance. Okay, it is very useful also because it recharges the snow, it brings some precipitation, which is very, very useful for the rabi crops, but at times it is very dangerous, or at times it is quite delayed also. Because of that, they become very, very devastating. Anticyclone. So cyclone is a low pressure atmospheric system. Anticyclone is high pressure atmospheric system. In cyclone, the wind was coming from high pressure towards low pressure, rising upward. In anticyclone, wind is going to get suppressed down and it is going to move towards the low pressure region. So there is no convection, no precipitation, okay, no rainfall, nothing. So this is a relatively more stable region. Anticyclone is a relatively more stable region. Anticyclone in the northern hemisphere is clockwise direction, in southern hemisphere it is anti-clockwise direction. Okay, so these important pressure belts you must try and understand. At the same time, you must also understand the important regions. Okay, now climatic region of the world, the last topic, and then this topic, climatology, will be over. So climatic region of the world. So just try to understand that whatever we have studied so far, here is the crux of all of these concepts. So climate of the world. So just try to understand that this is the important climate of the world, not just northern hemisphere. At the equator, 0 to 5 degree or 0 to 10 degree, north as well as south, okay, of the equator, we have equatorial climatical condition. We'll try to understand what is the rainfall, temperature pattern, and what is the type of vegetation that is grown, what is the livelihood of the people over these regions. On the other hand, we have the tropical monsoon, tropical savanna, the tropical desert, then we have warm temperate China type of climate, then central Asia or highland, then we have the Mediterranean type of climate, very, very useful for prelims. Mediterranean climate have been asked 2-3 times. Then cool temperate British Columbia climate, Steppes climate, Laurentian climate, okay, the taiga climate, tundra climate. So here different regions of the world is mentioned, and we'll first understand the characteristic, then we'll do the question. So with respect to the equatorial climate is distributed between 0 to 5 degree or 0 to 10 degree in some cases. It is also written as both is correct, north to south. What is the weather condition in this region? Temperature is relatively high throughout the year. There is no winter. Okay, it is summer and summer only. Okay, and summer is very peak. Summer is peak during equinox. Equinox happen, I hope you remember, during the March and September. So March and April and September, October month is relatively hottest of the whole year. Okay, so the peak is twice. No seasonal contrast means there is no winter, so there is no seasonal contrast. Then the night is hot, warmer, day is also hot, summer is there, no winter is there. So daily range of temperature is not very much. Okay, where temperature fluctuation is very less, and annual range of temperature is also very less. Okay, the temperature is high but range of temperature is less. Precipitation, the rainfall is throughout the year. Okay, daily rainfall between 2 to 4 p.m. and maximum rainfall happens twice in a year. That is equinox time, that is when the sun is overhead at the equator. Then during those March, April time, September, October time, the rainfall is also relatively high. Okay, because of very high temperature and precipitation, vegetation is evergreen, and mostly this region is like forest region. So tribal people lives over here, which basically does hunting, food gathering. Okay, then comes the monsoon region. Monsoon region is basically distributed in the northern hemisphere, in the southeast Asian region. Temperature, there is a seasonal contrast. They have some definite summer, definite winter, because monsoon is not throughout the year rainfall. So when the rainfall is not there, it is quite hot. When the rainfall is there, it is warm plus moist. Then there is a winter season, and there is monsoon retrieving season also. Diurnal and annual range of temperature is relatively high. Summer is hot, winter is cold, so annual range of temperature is high. Day is hot, night is cooler, So daily range of temperature is also high. Rainfall happens during the southwest monsoon time, like June, July, August, September, and during the northeast monsoon is during the November and December. Okay, so majority of the rainfall is because of southwest monsoon as compared to northeast. Vegetation is not evergreen, it is deciduous. Main occupation of the people living in this region is agriculture. Okay, then desert region. Desert regions are those regions wherein the precipitation is relatively less, evaporation is more. Precipitation is less, evaporation is more. So how does this desert is formed? This is formed in those regions which is under the influence of cold oceanic current. So cold oceanic current, those regions under the influence of cold oceanic currents will have a relatively cool and dry type of climatical condition. Under the influence of warm oceanic current, warm and moist climatical condition. So region under the influence of cold oceanic current, region under the influence of high pressure belt, because low pressure belt wala region mein precipitation will be there, high pressure belt wala region mein no precipitation. Offshore trade wind, that is here in this case try to understand that the wind is getting moisture from ocean towards land, from ocean towards land. Here in this case try to understand from continent towards ocean, moisture is being thrown. Moisture is not being brought, it is being thrown. More dryness will happen. Okay, then rate of evaporation is higher than the rate of precipitation. When all of these factors meets consistently for several years, so that region will become desert. Man-made desert is also taking place, desertification, because of deforestation, extensive irrigation and use of synthetic fertilizer. Okay, now here in this case just Mediterranean climate. This is a unique climate wherein the rainfall is in the winter, summer is dry, no rainfall in the summer. In monsoon mein winter is dry, summer is moist. Okay, and here it is the reverse case. So here the summer becomes same like desert type. Summer becomes very, very hot and it becomes very difficult for the survival for the vegetation. So vegetation does some modifications. Okay, so and accordingly like citrus fruits is being found over here, and viticulture is the major occupation for people living in this region. Okay, so the table, some data is given, and on the basis of that question is being asked. So you can expect a question from this region very, very oftenly, and for time being what is more important is understanding this climate change. So climate change is natural also, and it is man-made also. So climate change, natural factor. Man-made, everyone knows, Milankovitch cycle, which is a natural factor. So Milankovitch cycle is basically change in the circumnavigation of that of the earth. So what is this? When the orbital path, so we know that the earth is revolving around the sun in the elliptical orbit. Yes, at times it is close, at times it is far, and when it becomes, let us say, circular, when it becomes circular, when this orbit is changed circular, or it becomes more eccentric, okay, more elliptical it becomes. In both the case there will be climate change. Okay, the climate change can be positive, negative, both. Okay, then angle of tilting. Do we know that earth is tilted by 23.5 degree? Yes or no? But do we know that in past it had tilted till 22.1 and 24.5 also? Okay, so and presently it is 23.5. So if the more tilting takes place or less tilting happens, don't you think the change in the climate will take place? Yes, it is going to permanently change the climate. Then the direction of the tilt of the axis, let us say if it is tilted in this way and then later on the tilting becomes this way, so in that case also this tilting can take place, so that is known as precession or wobble. So because of all of these factors the climate change can happen. All of this is known as the Milankovitch cycle. So this climate change have happened several times in the past, and those changes were because of this natural reason. Present climate change is because of anthropogenic, which is very, very fast, which is unpredictable, and which is very, very unsustainable also. Natural climate change was relatively more sustainable, but man-made climate change is relatively unsustainable. So climatology is done. now is the time wherein we should be moving with the now smaller and simple topic, which is easy to do, that is the biomes and the oceanography. Okay, so we'll continue with the oceanography now. So here in this case of this topic oceanography, as we had initially seen, this is a simple topic, and there is 50% chance that UPSC may ask question from this area. So let us quickly go through the questions which UPSC have asked. Questions are asked on subtopics like ocean bottom relief, and with respect to this ocean bottom relief, the question focus on the trenches. So twice they have asked question trench and oceanic trenches and the respective location, in which location and which ocean they are located. With respect to the oceanic current, they have asked question in 2021, and this question is basically interrelation between two topic, climatology and oceanography, and we have in fact seen this question in climatology. They have asked question with respect to the ocean currents and what are the factors that influences. In the case of geography, always remember factors. Factors are very, very important. The major factors, since this is the world geography, so major factors, okay, or just general factor that influences any geographical phenomena are very, very important. Yes, there are local factors also that influences, but local factor need not be too much emphasized. Then counter currents, then the ocean currents and respective application or the usage of ocean currents, fishing ground and ocean currents, upwelling zone and the ocean currents, tide pe they have asked questions, which are the forces responsible for the tide. Okay, then neap tide, spring tide. Okay. Now the significance of the tides, and here is a very rare question, which in last 20 years only one question was asked: tidal current and tidal bore. Tidal current and tidal bore. We'll try to see this, the tidal current, tidal bore. Then coral reef. Now this is the area wherein you can more probably expect question. This question was asked in 2022 with respect to biorock technology. Again in 2021 UPSC had asked question. 2018 question was again with respect to the coral reef. 2014, okay, 2007. So in last 20 years there was around 17 question, and this is relatively an easy area, so you may not find it a lot difficult. So let us understand this topic now. Okay, so with respect to this oceanography, we have understood that these are some important resources that we should be covering. So ocean bottom relief. Let us first focus on this ocean bottom relief. Let me help you with the better diagram for the same. So in the case of oceans, how ocean formation must have taken place. So we know that as the evolution of the earth took place, the degassing phenomena happened, and these gases, when it came outside, condensation took place and precipitation happened. Okay, so roughly like 4 billion years ago from present, the formation of the ocean had taken place. Okay, and in the oceans, as we go in the interior of the ocean, there are different landforms that is being formed. There are valleys, there are mountains. Okay, so let us try to understand two important aspect. Valley, a very, very important valley that is known as a trench, that is formed at the place where convergence of the plate is happening, a continental plate and the oceanic plate when they converge. So in the oceanic side, this V-shaped valley, that is the trench, is being formed. I hope you remember we did this convergent plate boundary wherein we did the continent and the the ocean plate convergence. On the continent side, fold mountains form, and the ocean side is the trenches. On the other hand, when the plate is diverging, the magma rises upward. The magma rises upward, comes out, solidifies and forms mountain. These mountain in the water are known as ridge. So ridge is the mountain, long mountain range. Do you remember mid-oceanic ridge? We gave the example of mid-Atlantic ridge. So these are very long range of the mountains in the ocean. They are the longest mountain ranges in the world. And if we see in terms of tall mountain range, it is Himalayas. Okay, Himalaya is not the longest, they are tallest. Okay, so these two are important because of conversion and because of divergence. So let us see the overall picture over here. You consider the continental side, okay, and you consider the oceanic side. So this is the continental plate, though it is in the water, but this is the continental plate. Okay, continental plate, and this region is the oceanic plate. So on the continental side, this region, which is having very shallow water up to the depth of 200 meter, this is a continental shelf region. Beyond that, when the slope becomes relatively steep enough, it is continental slope region with the depth of 3000 meter. And then from the continental side, when the mountains or the landforms is eroded, those eroded material is deposited in the ocean. Okay, and it leads to the upliftment of these regions, continental regions. So that is a continental rise. Then comes the trench, which is a V-shaped valley at the convergent plate boundary of continental plate and the oceanic plate. For example, Mariana Trench, okay, in the Pacific Ocean. Further, from here onwards, it is the oceanic plate. Okay, oceanic plate, we get to see some mountains which is having peaks, some mountains which is having flat flat peaks. So those mountains are called as a sea mount and guyot respectively. For example, Emperor Sea Mount in the Pacific Ocean is very, very important. When these mountains rise above the water level, it forms an island. Okay, it forms an island, and these islands may be volcanic in nature as well. At the divergent plate boundaries, the magma oozes out, solidifies. Okay, these are known as a ridge, mid-oceanic ridge. Okay, and the rest of the regions where it is plain regions are known as abyssal plain. Okay, these are known as abyssal plain. And did we notice that UPSC have asked question on the trenches? Yes, twice they have asked question on the trenches. So we should be knowing the important trenches of the world. Along with that, there is one more important valley. This is known as a submarine canyon. So submarine canyon. So do you remember we did the difference between valley, then gorge, and the canyon and the U-shaped valley? Yes, on the continent side. Similarly, in the ocean side, there is this submarine canyon. So as the name indicates, this is formed because of the action of the sea water, that is waves. So trench is a V-shaped valley which is parallel to that of the coast. Okay, parallel to that of the coast, and submarine canyon is perpendicular to that of the coast. This is formed because of wave action, and trench is formed because of convergence of continent and oceanic plate. Both are valleys, formation is different and their location is relatively different. Now, what is observed is that UPSC have asked question on the important trenches. So we'll do the important trenches of the world. But before that, let us see this. The difference between bay, gulf, strait, choke points and isthmus. This year, there was this mains question related to the important strait and isthmus. I hope you remember last year they had asked question the importance of strait and isthmus with respect to the international trade. So we should be doing what are the important straits of the world. Many prelims questions are there on the straits, many prelims questions. So we'll do straits. Okay, we should know the technical difference. Okay, bay is what? All of these are water bodies only, but bay is relatively a small water body. Okay, you can see over here, it is surrounded on three sides by the water. One side is open to the, the sea, and the mouth is relatively wider open. Okay, the mouth is relatively wider. Okay, on the other hand, if you can see the case of the Gulf, so Gulf is relatively narrow. Gulf is a relatively long, straight, narrow. This is also connected to the open sea. So they are also surrounded on three sides by land. One side is connected to water, three sides by land, one side connected to water, relatively wider, relatively narrow. Okay. Gulf may be relatively small in terms of size. Bay may be small in terms of size. Gulf is relatively bigger. Okay, narrow mouth but bigger. Choke points. So these regions where, these regions, the Gulf regions may be an important choke points also. The straits may be an important choke points also. So the straits, I hope you remember what is a strait. Strait is that water body, that narrow water body that connects two water bodies. So strait is that narrow water body that connects two bigger water bodies. So this becomes a very, very important the passage for the ships, and a dominance in this region can create a dominance on the other water bodies also. So these are very, very important from geopolitics point of view. Okay, similar is the case with the isthmus. Isthmus is the land joining two major land, two bigger land, or it separates two water body, or it separates two waters. So these are important points wherein the important the geopolitical tension are seen. Important straits of the world is Strait of Gibraltar, Strait of Bosphorus, Strait of Hormuz. This year you may expect question related to strait. We'll see what are the important straits. So here, if you can see here in this case, that is this will start with the Strait of the Gibraltar. So Strait of the Gibraltar, we should be knowing it is between which two region, or it connects which two sea. So it connects Mediterranean Sea with that of the Atlantic Ocean. So it is between which two region. So you must see it is one side is Africa, Morocco, other side is the Spain. So it is Morocco or Spain. At the same time, there is a small region in the Spain side that is known as Gibraltar, occupied by UK. And on the Morocco side, there is this region known as Ceuta. Ceuta, it is a territory of Spain. Okay, so if the option comes Spain and UK, that is also correct. Or if it comes Spain and Morocco, that is also correct. I hope you're getting this thing. Then the Turkish Strait, it connects to Mediterranean Sea with that of, Turkish Strait is like there are two sub-strait within this. So we'll try to see which are the important straits over here. Then this is not a strait, this is Suez Canal. Okay, Bab el-Mandab Strait, very, very important. Then here, this is important now. The Strait of Hormuz, Bab el-Mandab. Bab el-Mandab is very, very important because the Red Sea is there in the news. Okay, Red Sea is there in the news. Tension in this region is quite high because of the recent geopolitics turmoil, because of the conflict between Hamas and Israel. And also the case of Black Sea. This is also very important for current perspective. You must definitely do this. Then this is the Malacca Strait, very, very important for India because India's majority trade with the East Asian or the Southeast Asian countries takes place along this route. So it connects Indian Ocean with that of the Pacific Ocean. Okay, and in order to counter that, China is constructing alternate canal over here by cutting this Kra Isthmus. It is a proposed one, and that was also a prelims question, Kra Isthmus. Okay, so these important this is important, and especially important from the mapping perspective. This year, very high chances Black Sea or nearby region and the Red Sea nearby region. Very, very high chances of question to be asked. Now, ocean bottom relief for the Pacific Ocean. We'll take individual ocean and important, the important bottom relief with respect to trench, with respect to important island arc, then islands, okay, volcanic islands especially. These are very, very important, okay, because we saw twice question was there on the trenches. So definitely you can expect a question over here. So it becomes very difficult when you see so many information all at a time. So what can be done is just draw the outline map of the ocean. Okay, just draw the outline map of the ocean, and then have layers of the information. Like in first layer, add all the important trenches. Then you write all the important island arc. These are constant, isn't it? The island arc or trenches, they are not forming every day. Yes or no? They are not international organization or policy to come up every day, right? So these can be asked. So now what can be done is this can be simplified. For example, in the case of ocean bottom relief of Pacific Ocean. So here this is the Pacific Ocean, and this is Australia and New Guinea, then Philippines, Japan, and East Asian countries. Okay, then you have North America and the South America. So layer 1 of information is the trenches, as I had said. So important trenches, that is climatic, Tonga. Okay, then the Philippines, Mariana Trench, the deepest trench in the world. Okay, Ryukyu, then Japan, Kuril, Aleutian Trench, Middle American Trench, and Peru, Chile Trench. Okay, these are important trench. What is to be studied is in which ocean they are located, at least if you know this. So here less information means more you can retain, right? So that is the advantage of notes making, especially micro notes. Micro notes can be very small and it can be revised many number of times. Okay, so having done the basic fundamentals and all, there are important topics in which UPSC is bound to ask question, and on those area you should definitely make micro notes, not the entire subject but those probable area. And you should do the analysis, like on which topic you should make micro notes. So you should do analysis by looking into the previous year frequencies of question. Okay, second is discuss with the teachers or the senior students, okay, who have some years of experience in UPSC, and then make the micro notes. And trust me, having made the micro notes, you will have maximum confidence on those those topic. Okay, let us proceed ahead with another set of information. We have already seen some important trenches. Now you may write some name of the countries also. Okay, important seas has become very, very important. Then here this is New Zealand, Coral Sea, Solomon Sea, Arafura Sea, Timor Sea, South China Sea. South China Sea is important because UPSC have asked mains question, prelims question both. South China Sea is usually disputed because of China and the surrounding countries. Okay, then Philippine Sea, Sea of Japan. Recently they had asked question related to island in the Sea of Japan or the East Sea. Then Bering Strait. Do you remember Bering Strait? They had asked question Bering Strait. So there is a Bering Sea also. Then Gulf of Alaska, Gulf of California. Okay, so simplification of the work takes effort and it takes time, but having simplified it successively, you will be dedicating less time over here. So likewise for the other ocean also, it must be done. Having done for the Pacific Ocean, for the Atlantic Ocean also, it should be done quickly. So here quickly you can see with respect to this Atlantic Ocean, some important, what did I say, trenches, important island arc. These island may be volcanic or not volcanic in nature. So Atlantic Ocean, mainly it is divergent plate boundary, divergent. So divergent may mainly you will get to see ridge and less of trench. And in the Pacific Ocean, what did we see? Convergent plate boundary mein did we see ridges? No, we saw trenches. So convergent plate boundary mein trench, divergent plate boundary mein ridge. So mainly you will get to see ridge. For example, this mid-Atlantic ridge, there are various ridges. Okay, and you do not need to memorize all of these ridges. Okay, so here very, very important is trenches is South Sandwich Trench. This was a UPSC question. Then Puerto Rico Trench, South Sandwich Trench, Puerto Rico Trench. These two trenches, if you remember, that would be more than sufficient. And the major trench, that is the mid ridge, that is the mid-Atlantic ridge. Similarly, you can proceed with the Indian Ocean. There are some important ridge, some important trenches. Okay, so with respect to some important ridge like the Southwest Indian Ridge, okay, this over here, Chagos okay, Chagos Lacative Plateau. Okay, then mascarene is very important, especially in the case of the Indian monsoon. We are going to understand the significance of this plateau. Okay, then Chagos Ridge. Okay, then dementia fracture zone. This was a UPSC question. Dementia trench basically. Okay, so dementia trench, Java trench, another important trench. So these are some important landforms in the case of the Indian Ocean. Now here is a question: in which one of the following ocean is dementia trench? Indian Ocean. Okay, very simple. Then here, match the list. Aleutian trench, we just saw, it was there in the Pacific Ocean north. Okay, climatic trench, again Pacific Ocean south. Then Sunda trench is there in the Indian Ocean. South Sandwich trench, we just saw Atlantic Ocean. Very simple. Okay, so this area is going to be simple enough, not so difficult. Now temperature of the ocean water. We saw the temperature distribution in the case of the climatology. We studied that in the case of climatology, the temperature distribution is not uniform. At places, temperature is more or less, and these are influenced by several factors. So in the case of the ocean also, the temperature is distributed because of several factors. So factor that influences the temperature of the ocean. So latitude is a very important factor. Okay, in the low latitude region, the ocean is relatively warmer. In the high latitude region, colder region, the temperature is relatively less. Then prevailing wind, that is because of the trade wind. The wind blows the surface water. Yes, wind blows the surface water. So when the surface water is blown away, so wherever it is being carried, surface water is relatively warm because it receives energy from the sun. Okay, so in one region it is going to be warm oceanic surface water. On the other side, it is going to be cold oceanic surface water. So wind is an important factor for variation in the ocean temperature. Then unequal distribution of land and ocean. We know that in the northern hemisphere, land is 40% and southern hemisphere land is 20%. So northern hemisphere is going to be relatively more warmer because of the land. Southern hemisphere is going to be relatively more cooler because of more of dominance of water. Okay, and of course oceanic currents, they also transport the heat, okay, from low latitude to the high latitude region. So these are some important factors that affects the temperature of the ocean. Okay, latitude, prevailing wind, unequal distribution of land and ocean, and the ocean currents. So in the case of vertical distribution of the temperature, so just understand, it's quite logical that surface water of the ocean will be warm because it receives heat energy from the sun, and as you go deep in the water is going to become cooler and cooler. Yes or no? So from the surface, high temperature, bottom, cooler temperature, lesser temperature. Okay, so up to certain depth, the temperature is relatively high, warm. Okay, then after a certain depth, the temperature is relatively colder. So these are water mass. This is warm water mass, this is cold water mass, and in between these two there is a region where there is a sudden fall in the temperature taking place, sudden fall. Okay, so that region is known as thermocline. Okay, thermocline. So this is relatively warm water mass, cold water mass, thermocline, the region where sudden change or sudden fall in the temperature takes place. Horizontal distribution of the ocean, as I am moving from low latitude region towards the high latitude region, temperature keeps on decreasing, isn't it? The temperature keeps on decreasing. So this decrease in the temperature is because of availability of the sunlight. Yes or no? So at the equatorial region, ocean is going to be relatively warmer, but maximum temperature will be in the tropics. Do you remember in the case of climatology, we draw the same diagram? So here in the case of ocean temperature also, ocean ka maximum temperature is not at equator. Ocean ka maximum temperature is at tropics. Okay, and as the latitude increases, temperature starts to decrease. Okay, ocean salinity. Now on the temperature distribution of the ocean, there are no question as such, but on oceanic salinity, there are questions. So ocean salinity, what are the factors? You must have been to sea, and you know that sea water is quite saline. So what is the factor responsible for salinity? So factors responsible for salinity is the salt present in the water. Yes or no? Salt present in the water, but the salinity is not same throughout. Okay, there is variation in the salinity. What is the reason? Evaporation and precipitation. When the rainfall is more, rainfall will provide fresh water, salinity will decrease. Evaporation will evaporate the water and the salt will remain, isn't it? So when the evaporation is more, fresh water will be evaporated, salt will be remaining, so salinity will be high. When precipitation is more fresh water will be added, so salinity will go down. Then fresh water from rivers or melting of the glacier, they also play important. Prevailing wind, the wind may carry the water from one region to another region. Along with the water, even salt will be carried. So one region will be having less salinity, other regions will be having more salinity. And ocean currents, of course, ocean currents will also be carrying this water. Okay, thereby leading to variation in the salinity. The salinity is measured in terms of ppt, parts per thousand, and it is written as such: ppt, parts per thousand, that is amount of salt present in 1000 gram of that of the water. Okay, so example is Lake Van, which is in Turkey, having very high salinity. Okay, in 1000 gram of the water, there is this 330 gram of salt, very high salinity. When the salinity is more, density, water will become more denser. Yes or no? The density of water will increase. When the water is more denser, then what will happen in that case? That any object which is having less density than that of the water will continue to float on the surface. So is the case with the Dead Sea. Dead Sea, which is shared by Israel and Jordan, have very high salinity of 238 ppt. Great Salt Lake in Utah in the USA, again very high salinity, 220 ppt. Now there are some important constituents, that is some important minerals that is dissolved. So these minerals are basically the chlorine, sodium, okay, sulfate, magnesium, calcium, potassium, and bicarbonate. Try to memorize this in the descending order: chlorine and sodium. So sodium chloride will be relatively very high in terms of concentration, followed by sulfate, magnesium, calcium, potassium, bicarbonates. Okay, now here we have just understood all of these factors. In the case of the Indian Ocean, the Bay of Bengal would be relatively having less salinity as compared to the Arabian Sea, because of availability of the fresh water from the Himalayas, from the peninsula, which mainly flows into the east. Okay, now proceeding ahead with vertical distribution of salinity. So with respect to the vertical distribution of the salinity, horizontal distribution of the salinity, it is very important. Vertical distribution of salinity. See, in the case of surface water, so surface water evaporation will be taking place because of sunlight. Evaporation will be taking place because of the sunlight. So when the fresh water is evaporated, evaporation will be taken place of the fresh water, salt will be remaining, so salinity will be high. Yes or no? Bottom water, there is no sunlight, so no evaporation. Yes or no? No evaporation. So in this case, whatever is the amount of the salt, so it will be relatively less as compared to surface water, as compared to that of the surface water. So surface have more salinity as compared to the bottom. Okay, but this is the case with the low latitude region. Low latitude region, that is the tropical region, because sunlight is there in the tropical region. In the polar region, if you go, there is no sunlight, isn't it? So over there, the variation in the salinity would be relatively would be relatively different. So if you take the case of high latitude region में sunlight is not there, but there are glaciers will melt, it will supply fresh water will reduce the salinity. So surface water में less salinity is there, and as you go down, okay, salinity will increase. Okay, so once again, in the low latitude region, surface water have high salinity, and in the high latitude region, surface water have low salinity. It is ulta. Okay, so those region which is having relatively high salinity, and there are certain region which is having relatively low salinity, and there is a region where the salinity changes very rapidly, that is halocline. We just saw thermocline, right? So thermocline is the region where the temperature variation takes place very, very fast. Halocline is the region where salinity variation takes place very, very fast. Okay, if we see with respect to that of the horizontal distribution, so in the equatorial region, salinity is relatively high because sunlight is high, so more evaporation will be taking place, and as we go in the polar region, the salinity tends to decrease. Maximum salinity as the tropic, because maximum temperature is at the tropic, means more evaporation is taking place in the tropic. So more evaporation in the tropic, so what is left out is salt. Okay, this type of graph is very, very important. You cannot keep on memorizing the values, right? Because values you are bound to forget. Okay, so now we have understood the temperature and the salinity. So it is like I have just mentioned that it is usually salinity is measured in terms of the the amount of salt present in 1000 gram of the water. Okay, average salinity is 24.7. The salinity beyond 24.7 is termed as the brackish water. Salinity of the ocean is average 37. We have understood all of these factors and the role of salinity. See, salinity will be affecting the density. More salinity, more density, and density will be affecting navigation, movement of the ocean currents, and distribution of the organism. There are some organisms that can survive in more salinity. Some organism, they are very sensitive to change in the salinity, so it will have influence upon all of these. Okay, it will also have effect upon the thermal expansion and cooling. Okay, with variation in the salinity, the water heating and cooling may be affected. Okay, it may become when the salinity is relatively high. Okay, see, in the fresh water the heat transfer relatively faster. Okay, and in that case less salinity, more faster heating. In the case of more salinity, less faster heating will be taking place. Okay, with respect to the vertical distribution, we have just understood the low and the high latitude region. Ocean currents now. Ocean currents. Now with respect to that of ocean current, there are like couple of questions being asked over here. It is nothing but the surface oceanic water that is moving in a particular direction over a long distance, and this motion is because of wind force. Wind is drifting this water over a certain distance. Okay, so this ocean current is nothing but the slow surface. They are not very, very fast, and this is being affected by several factors like wind, drift force, Coriolis force. So what it is, a fluid, so Coriolis force will act upon it. Do you remember, in northern hemisphere towards the right, in southern hemisphere towards the left? Orientation of the coast. Orientation of the coast is, let us say the oceanic current is moving and there is a coast. So the oceanic current is not going to jump over the coast, isn't it? So it is going to move either towards the right hand side if it is in north hemisphere, or towards the left hand side if it is in the southern hemisphere. Okay, and density of the water. When the water is more denser, it will be moving much slowly. If the water is less denser, it is going to move relatively faster. Okay, then with respect to this surface oceanic current, there is also a bottom oceanic current, because the water cannot just go and just pile up somewhere, right? Because water is being deprived from this region and it is carried over here in this region. So what happens is the denser water will sink down, and the water which is which is being carried from here to some else place. So water is replaced by the water coming from below. So this is a zone where the water is rising upward. So it is the upwelling zone. Upwelling, very, very important zone. So in the case of this upwelling zone, what is seen is, along with the rise of the water, the nutrient is also being carried upward. The nutrient transportation takes place. This nutrients is very, very important for the growth of the phytoplanktons. Phytoplanktons is aquatic plants. When the aquatic plants is there, then zooplanktons, the aquatic animals feeding upon the phytoplanktons will be found there, and the small fish, big fish. So there is a very high biodiversity in the upwelling zone. These zones are very, very important. Okay, so if we proceed ahead. Okay, now upwelling zones are very, very important because productivity in this region is very high, because the ocean is going to transport what? Ocean is going to transport minerals. See, if you take the case of mid-oceanic ridge is where the magma is rising upward. Okay, so when the magma is rising, it is bringing new elements, new minerals over there, and when this is being transported, okay, so certainly the biodiversity is going to be very, very high. So you're going to expect new living organisms in such region. Okay, so these are very important zone for the study by the oceanographers. Now, with respect to the oceanic currents, how does the movement, circulation takes place? Consider this important diagram. Here, in the case of this is the 0 degree latitude, 30 degree north, 30 degree south, 60 degree north and 60 degree south, and this is the trade wind, northeast trade wind, this is the southeast trade wind, and this is the westerly, this is also the westerly. Okay, so when the trade wind is blowing over the ocean, it is going to transport this oceanic water from east towards the west. Yes or no? And in the north hemisphere, now coast have come, so under the influence of Coriolis force, and orientation on the coast, it is going to move towards the right. Now westerly will push it more towards the right. Okay, westerly will push it more towards the right, plus Coriolis force will continue to act. Okay, now again the coast have come, again under the influence of coast and the Coriolis force, again it is going to take a right, so it is going to complete one clockwise direction in the northern hemisphere. Okay, the same will happen in the southern hemisphere, anti-clockwise, under the influence of trade winds, westerlies, orientation on the coast and Coriolis force. It is going to move in the anti-clockwise direction. So this circulation of this oceanic current is known as gyre. It is known as a gyre. So this oceanic current in the low latitude region, these are relatively warm because sunlight is there, so surface oceanic current is relatively warm, and this warm oceanic current is transported to the west of the ocean, or can I say east of the continent? Yes or no? West of the ocean. Okay, if it is west of the ocean, it is east of the continent. So this region is going to have warm and moist climatical condition. We have studied this, and this region is going to have a relatively cool and dry climatical condition, arid condition. Okay, and desert formation will be over here, and it is going to be a region with high precipitation, and the rainforest can be expected over here. Okay. When it is going upward, the surface oceanic current is moving in the high latitude. So from the polar region, from the north or the southern hemisphere, the polar region, melting of the glaciers will be taking place, and they will be providing cool water. Okay, thereby this warm oceanic current will be converted into cold oceanic currents. So cold oceanic current is going to continue its path. Again, when it comes to the tropical region, again under the influence of sunlight, it is going to become warm again. Okay. So the cold and warm oceanic currents have their respective influence upon the climate of the coastal region. When the cold and warm oceanic current is meeting, okay, then moderation effect will be taking place. Okay, that was also once UPSC question, that where is the major fishing ground in the ocean? So major fishing ground is basically this region where the warm and the cold oceanic current is meeting. Okay, just try to understand the Pacific Atlantic Ocean. This is Atlantic Ocean, North America, South America. This is Europe and Africa. See, by now you should be very well versed with the maps, and you may not have to be told, you know, what is this continent, what is this ocean, just by looking into the diagram. Objective is not to explain you the map. The objective is to explain you the concept on the map. Okay, so this is the Atlantic Ocean, North Equatorial Current, and this is the North Atlantic Drift. Okay, North Atlantic Drift. This is North Atlantic Drift. Over here, just try to understand that this Greenland is much above, so there is no blockage of this North Atlantic Drift because of the continent. So westerly continues to pull it more towards the east. Okay, and because of that, warm oceanic current is also found in these regions. Okay, on the west of the western hemisphere in the high latitude region. So because of this warm oceanic current, what happens is the temperature in this region is relatively, in the coastal region, the temperature is relatively high, and at the same latitude, in the same latitude here in this region, because of melting of the glaciers, cold oceanic current is found. Because of very low temperature, this coastal area is relatively frozen, and over here this coastal area is not frozen because of warm oceanic currents. Same latitude but different oceanic currents and different influence. Okay, now just try to understand what will happen when the warm and the cold oceanic current is meeting. So see, when the surface is hot, evaporation will be taking place, and condensation, precipitation will happen, isn't it? When the surface is cold, will the evaporation take place? No. The air which is below, it will condense down only. It will not go up and condense, no? Okay, it will condense down only. So that is a cloud, and same phenomena happens when the surface is cold. The cloud is formed on the ground. This cloud which is formed on the ground is known as fog. Okay, it is known as fog. So fog is nothing but the cloud that is formed on the ground. Now, what are the factors that influences the formation of the fog? Is humidity should be high, temperature inversion. Temperature inversion is the phenomena wherein we have studied that as the height increases, temperature decreases. This is a normal phenomena. But as the height increases, if the temperature also increases, that is a inverted phenomena, temperature inversion phenomena. Okay, so as the height increases, temperature decreases. When will that happen? When the surface is warm. Okay, when the surface is warm or hot enough, air will be rising upward, temperature will be decreasing. Okay, temperature will be decreasing. So this is a normal phenomena, and in this case the surface is cold itself. So why will the air rise? So it is cold below and it is relatively warm above. So as the height increases, temperature also increases. So these denser air will remain below only. So this phenomena where the temperature increases with the increase in the altitude is known as inverted phenomena or temperature inversion. Okay, this is an important concept in the climatology also. So here what happens is when the warm, so like smog is smoke plus fog, and when it is like chemicals and the chemical reaction taking place, these chemicals or the pollutants like sulfur, hexafluoride, ozone, peroxyacetyl nitrate, hydrocarbons, when they react, it leads to the formation of smog. So what we are trying to understand is what will happen when the warm and the cold oceanic current is meeting. When the warm oceanic current hai, to the water will be converted into water vapor. Okay, water vapor, it means the air will be having relatively high humidity. In the case of cold oceanic currents may the surface is relatively colder. Yes or no? Surface is relatively colder. So when this water comes in contact with this cold surface, don't you think this water is going to get condensed? Yes or no? This water vapor is going to get condensed, and fog formation will take place in the ocean. Fog formation is going to take place in the ocean. So this is that region where the moderation of the oceanic current is taking place. And what is the climatical condition? is the temperature inversion phenomena happens and the fog formation takes place. Because of this moderating effect, plus there is upwelling also. Because of this upwelling, there is high biodiversity, especially the fishing is very high in this region. Before proceeding with the unique characteristic of the Indian monsoon, let us proceed ahead with the name of this oceanic currents, and also we'll do some important question. So we were talking about, let us consider Atlantic Ocean. So Atlantic Ocean, where this is North Equatorial Current, this is Gulf Stream, North Atlantic Drift, Norwegian Current, and we had seen this also. This is Labrador Current, this East Greenland Current. Same time in the Southern Hemisphere, South Equatorial Current, Brazilian Current, okay, then East Wind Drift, then Benguela Current. Similarly, in the case of Pacific Ocean, North Equatorial Current, and this over here, you can see over here, this is Kuroshio Current, and then Oashio Current, okay, and then this North Pacific Current, okay, then Californian Current, Alaskan Current over here. Similarly, in the Southern Hemisphere, South Equatorial Current, something over here is here, the Australian Current, then followed by West Wind Drift, okay, then the Peru Current. In the case of the Indian Ocean, this Somalian Current is very important. North Equatorial Current, Somalian Current, South Equatorial Current, then Agulhas Current, West Wind Drift again, and the West Australian Current, we have Lewin Current. Okay, it is important that we should be knowing the name of the major oceanic current. Somali Current have a very important impact upon the Indian monsoon, because Somali Current is going to bring some moisture towards India. Okay, it is going to bring some moisture towards India, thereby helping in the Indian monsoon. Okay, so if we look into some of the questions with respect to those oceanic current, so these are very simple questions. Oceanic currents are slow surface movement of water in the ocean. True. Oceanic current assist in maintaining earth heat balance. True, because it is going to transport heat from the tropical region towards the high latitude region. Okay, ocean currents are set in motion primarily by prevailing wind. Yes. Ocean currents are affected by configuration of the ocean. Yes. Even if it is written as configuration of the coast, then too it is correct. Okay, all are correct here. Next, consider the following statement. The question says, which of the above factor influence the oceanic current? Rotation of the earth. The rotation of the earth will produce Coriolis force. Coriolis force will change the direction of oceanic currents. Correct. Air pressure and wind. Yes. Wind, prevailing wind. Then density of the ocean water. Yes. And last option, revolution of the earth. Revolution of the earth do not have any impact upon the ocean current. Fourth statement is wrong. Okay, we did this. Now, can you notice one thing over here? Can you notice this, North Equatorial Current, South Equatorial Current, and there is a current which is blowing in between. Similarly, in all of these regions, between these two equatorial current, there is a current which is blowing in the opposite direction. This current which is blowing in the opposite direction is called as the equatorial counter current. Equatorial counter current. Now the question is, why do the equatorial counter current blows? Okay, or the equatorial current blows in one direction, the equatorial counter blows in the opposite direction. So what is the reason for this opposite flow? Just try to understand by logic that two oceanic current, north equatorial current, south equatorial current, they are going. Okay, the north gets deflected towards the right because of the Coriolis force, south get deflected towards the left because of the Coriolis force. So what happens is, the water is being transported from one region to the another region, that is from the east toward that of the west of the ocean. Okay, this goes in the right, this goes in the left. Okay, so what about the water which is accumulated in between the north and the south? It is going to get reversed back. It is going to come back, because when the water is being transported from one region to another, so what happens is, over a period of time, a slope is created. Okay, so the water equatorial counter current slide along its own slope. okay, slide along its own slope. So this is a very interesting question. What explains the eastward flow of the equatorial countercurrent? Or the rotation on the axis? No. Convergence of two equatorial current? Difference in salinity? This is incorrect. Occurrence of belt of calm near the equator? This is also incorrect. See, the primary reason is this equatorial current. If the two equatorial current is not blowing, if it is not flowing, how will the counter equatorial current flows? Now some might be confused with the word convergence. You must be taking it that since two equatorial current is diverging, okay, in the respective hemisphere, so the equatorial counter current is flowing. So the UPSC deliberately gave this type of statement so that you get confused. It is diverging in the west, but when it comes back, it is converging at some other place. Yes or no? It is converging here, then it is going ahead in the west, then it is diverging. So if we use the term divergence, it is at some place. Convergence, it is at some other place. Both is correct. Yes or no? This is a primary reason. Okay. So in such type of question, when factor is being asked, usually there is primary factors or the important factor. There are secondary factors also. Always give significance to the primary factor, even if there are other factors are if minor factors, okay, and if you're supposed to choose one option only, go with the most important factor, okay, because in the case of geographical phenomena, there are many factors that influences. Okay, now Indian Ocean currents. Now we have just studied that in the case of the Indian Ocean, there is this the Somali current, we have just studied. In the case of this Indian Ocean, Somali current, North Equatorial current, South Equatorial current, all of this. So do you know that there is monsoon? And in the case of this monsoon is seasonal in nature, periodic in nature. In one season it comes, in another season it goes. So in one season when it is coming, it is going to bring this warm oceanic currents towards India. When it is going back, it is going to take this oceanic currents away from that of the India. So there is a reversal of this wind, and at the same time there will be reversal of the oceanic currents. Okay, there is a reversal of the wind and there is a reversal of the oceanic currents. Okay, so just try to understand here that in the summer as the southwest monsoon wind is coming, the oceanic currents will be coming towards India, and it is going to form this clockwise direction. In the winter, when this wind is retrieving back, it is again going to drag or drift this oceanic water away from the India, and it is going to form this anti-clockwise direction. So there is a reversal of wind, and in accordance with that, there is a reversal of oceanic currents. South hemisphere, South Indian Ocean wind reversal does not take place. This reversal take place in the north of the Indian Ocean. Okay, so you can expect a question related to this. Oceanic currents have very important influence upon the local weather condition, be it warm oceanic currents, be it cold oceanic currents, be it the mixture, and the other important factors like fishing and the cyclones and the navigation. Okay, here is the question that I was talking about. The most important fishing ground of the world are found in the regions where the warm and cold oceanic current is meeting. So you can see option A and C, warm and cold atmospheric current, and option C, warm and cold oceanic current. So one hint for the question, like if you happen to come across question wherein you don't know the answer, okay, so look in for the options which is relatively similar. So there will be definitely two options which is similar, okay, with one or two word different, and two option will be altogether different. So the two option which is altogether different is 100% wrong. Two option which is relatively similar, there is answer between these two only. Okay, so you are 50% close to the correct answer, then you can take the risk. Okay, if there is a fear of failing, so you should be taking the risk at that time. When you are safe enough, don't take the risk. Okay, another question. In the context of ecosystem productivity, marine upwelling zone are important as they increase the marine productivity by bringing the nutrients to the surface. See, productivity is increased by plants. Decomposer is consumer, isn't it? Decomposer is consumer. Consumer will not increase the productivity. Bottom dwelling organisms, they are consumer. They will not do the productivity. Productivity is done by plants. So 1 and 3 is wrong. Don't get carried away by the option that all will be responsible. Now, this is there in the news, current affair based topic, thermohaline circulation. So in the case of thermohaline, we have seen oceanic currents, and this is the oceanic currents, which is the oceanic current connected from one ocean to that of the another ocean. So it is basically a big loop of the oceanic water, okay, that is interconnected to each other. So usually the surface water is relatively warm, so surface oceanic currents, and then the bottom oceanic currents or the cool subsurface water. So basically it is a circulation, it is a loop, okay, and this loop is connected to the other ocean also. Okay, the water is there in the surface because it is relatively less denser. The water is below because it is relatively more denser, and there is a mechanism wherein they both are moving in a particular pace because of several factors like the density of the water or because of motion of the wind. Okay, so these factor influences the circulation of these oceanic currents. They are very, very important in maintaining the heat balance, isn't it? They will transport the heat from the surplus region towards the deficit region. There it will become cold, it will become dense, and it will sink, okay, and then it will travel in the other region, thereby forming the circulation. Now what is there in the news is this circulation is basically, there is problem that is about to happen to this circulation, the circulation. Now let me ask you the question, after that I'll answer. See, because of global warming, listen to the question, because of global warming, the thermohaline circulation is going to become faster or slower? Because of global warming, okay, answer this in the mind. The thermohaline circulation is going to become faster or slower? So some of you might think that the surface water will become more warm and more hot, and then it will be warm water becomes less denser, it is going to move faster, isn't it? But see, only the surface water movement is not sufficient. Even the bottom water should be moving. When the water is warm enough, when the water is warm, okay, it is relatively less denser. It will remain up only. Yes or no? It will remain up only. And for the water to sink down, it must lose away the heat. It will become denser, and it must become cooler, and then bottom oceanic currents will continue, isn't it? So because of this global warming, the surface oceanic currents will continue to remain warm enough, and it is not going to sink down. When it will not sink down, the bottom water will not flow. When it will not flow, this circulation will become slow. Okay, circulation is going to become slow, it is not going to become faster, and because of slow circulation, the balance of the heat that is being transported from one region to another region, that balance of the heat is going to get disturbed. You must have come across this AMOC, Atlantic Meridional Overturning Circulation. It is basically the same circulation, only in the Atlantic region. It have tried to explain that this AMOC, Atlantic Meridional Overturning Circulation, is slowing down, okay, and this slowdown is because of global warming. So what impact it is going to have? When the slowdown happens, heat balance will not take place. The balance of the heat will not take place. Okay, so in the case of the impact, all of these impact in the pictorial manner is mentioned over here. So when the slowing is being happening, so what will happen is this warm water will be accumulated in these region, will be formed in this region. The permafrost in these region will be melting, thawing will be taking place. Okay, since we have already studied that AMOC is a part of bigger thermohaline circulation, so the overall circulation is going to get affected. Okay, the Amazon rainforest is going to get affected. Okay, because of the slowing down. There will be disruptions in the tropical season, especially in the case of the monsoon. Monsoon is going to get affected. Okay, the cloud formation is going to get affected. Okay, then those regions which is having the permafrost, that is the permanently frozen soil, they all are going to get affected. Okay, so in general it is going to be a very, very negative impact. Okay, and this is what is being discussed in the news also, that in the recent years that slowing down might have started, and it is going to not stop completely, okay, but it will slow down, and negative consequences may follow. With respect to waves, now UPSC haven't asked question on waves, but you may expect question, because this is that area wherein it is also technical, but haven't touched this area. So what is the oceanic current? It is slow surface movement of this water in the ocean, which is over a certain distance, certain direction, because of wind drift force. And wave is basically the energy which is being energy of the water which is transported from one area to that of the another area. Okay, one area to that of the another area. So basically waves carry the wind. The wind carries the wave ahead, or the surface water ahead, and the wind energy is transported to the wave, isn't it? The wind energy will be given to that of the wave, and the water is going to get transported ahead. But as it moves ahead, there is gravity also. The gravity is going to pull the water downwards. Okay, and because of that, this circulation will be formed. So it is not going to continuously move. Okay, small circulation, and then it is going to move ahead. Okay, small circulation, it is going to move ahead. So as the wind tries to drag it ahead, okay, depression will be created. Energy will be transported from wind to that water, and this, when the depression is created, that is trough is created, then a rising will be at some other place, that is crest is created. Okay, and this will be pulled down again because of the gravity, and you cannot see the circulation happening, but the mechanism is that circulatory in the nature only. Okay, and this way the water is going to continue to move ahead, and this energy that is transported from wind to that water will be carried ahead. Okay, so you can see this when it is movement in the inverse manner, it is going to have its specific direction of the movement. It will have the wavelengths, frequencies. Okay, now for this circulation to happen, the depth of the water should be sufficient enough, because what will happen is, when the circulation happens and the depth of the water is quite shallow, when it is shallow enough, so what will happen is, it is not going to circulate properly below, so the water will rise up. And then along the coastal area it is going to splash. So as you can notice over here, the wavelength is relatively more, amplitude is less, because the water is quite deep, and as it comes near the coastal area, the wavelength is decreasing and the amplitude is increasing, because it is coming to the coastal area, and it is becoming more and more shallow. So the energy is going to get transported upward, and then it is going to splash. Okay, so waves which is relatively small, those are ripples. Wave which is relatively bigger are called as rock waves, and waves which is very, very huge, big, and it is going to create a big disaster, that is called as a tsunami. Tsunami is a term given by Japan. Tide, don't get confused by tide and the wave. Okay, tide is basically rise in the sea level, fall in the sea level, and wave is the energy transported along the surface of the ocean water. Okay, so this energy transported is because of the wind, and tide, that is rise or fall in the sea level, is because of gravitational pull by the moon and also by the sun, gravitation pull by the sun and the moon. So here in this case, tide, which is periodic rise and fall in the sea level. So this periodic rise and the fall in the sea level is because of several factors. One factor we understood is the gravitational force by the moon, also by the sun. Moon have more influence because moon is close enough, and centrifugal force also, because something which is rotating have centrifugal force also, so the object tends to be thrown away. Do you remember the earth was spherical, and because of continuously rotation, centrifugal force, and the earth became bulgy in the equatorial region, flattened the pole. In a similar manner, when the earth is rotating, so the water tends to be thrown away from the axis of rotation, and the bulge, is formed. So this bulge is basically the high tide. So centrifugal force of the earth, gravitational force of the moon and the sun is very, very important forces. So just try to understand how does this comes into picture. Consider sun, moon and the earth. So moon is exerting gravitational force. The sun is also exerting gravitational force. So there is going to be pulling of this water, and high tide can be observed. On the other side, centrifugal force will be acting, and the high tide will be on the other side also. Okay, other side also, because of centrifugal force. Okay, so now we'll understand some easy aspect, and then we'll proceed ahead with the some difficult task. Now we have already studied that in the case of solar and the lunar, the year is 365 to 360 days, 6 days, lunar is 354 days, and here we have also understood all of these factors, right? So basically in a month, which is like lunar month, 29.5 days, which is like complete one revolution of the moon around that of the earth. So at times moon is here, at times it would be here, at times here, at times here. So basically it is going to be a different quarter, okay, in one revolution. So consider this position. Consider position number 4. Consider position number 4. In this case, when moon is between earth and the sun, so there is a gravitational pulling by the moon, there is a gravitation pulling by the sun, so it is going to be high tide. So this position is basically what? No or new moon day. Okay, no or new moon day. So it is going to be high tide on no moon day or new moon day. Okay, this high tide is also known as spring tide. Okay, on the other side, consider when the moon is in this position. Okay, moon is in this position, so gravitation pulling by the moon, gravitation pulling by that of the sun, plus there is also centrifugal force acting on both the directions, so high tide in that case also. So when the moon is over here, it is full moon day. Okay, full moon day, that is you are able to see the moon completely. So full moon day, high tide, spring tide again. Now consider this position 1 and 3. So in this position, what happens is moon is pulling toward itself. Okay, sun is pulling this way. So moon pulling is countered by centrifugal force over here. Sun pulling is countered by the centrifugal force on the other side. So all these forces, they counter each other. So when the moon is at this quarter, okay, it is low tide or the neap tide. Similarly, the same happens when the moon is in this quarter. Okay, so just try to understand, on new moon day and full moon day, it is going to be high tide or the spring tide. On first and the third quarter, okay, it is going to be low tide or the neap tide. Okay, now the frequency of the high tide and the low tide, we'll try to understand. So in 1 month, one high tide. In 1 month, one high tide, then low tide, then high tide, then low tide. It means 2 high tide and 2 low tide, right? 2 high tide and 2 low tide. So monthly tidal cycle, if we say high tide followed by low tide, high tide followed by low tide. High tide is on new moon day and new moon day or no moon day, and on full moon day also. And low tide is on half moon day or the first and the third quarter. Now with respect to the diurnal, everyday tidal cycle, see, do you remember that moon, 1 day of the moon is considered as 24 hours and 52 minutes. 24 hours and 52 minutes. See, Earth rotates in 24 hours, but when the Earth rotates 24 hours, Moon would have also done revolution plus rotation by some degree. Yes or no? They would have also done. So there will be a mismatch with respect to the axis. So what happens is the Earth have to rotate further. The Earth have to rotate further 52 minutes, so that Moon and the Sun, Moon and the Earth, their reference point is matched. Once again, Earth takes 24 hours for rotation. Moon also would have rotated by some degree, and some revolution would have also taken place. So there is a mismatch. Earth have to rotate further 52 minutes, okay, and then the reference point is matched. So 24 hours and 52 minutes of Earth is considered as 1 day of the Moon. So in that 1 day of the Moon, that is 24 hours 52 minutes, there is one high tide, one low tide, one high tide, and one low tide again. Okay, same region is going to have this high tide in 6 hours and 13 minutes. 24 hours 52 minutes divided by 4, so 6 hours 30 minutes, one high tide, again the low tide will come, then again high tide, again a low tide will come. So diurnal tidal cycle is high tide followed by low tide every 6 hours. Okay, monthly tidal cycle is a high tide followed by low tide, take after every 1 week roughly. Okay, then in terms of very high tide and very low tide, so just try to understand very high tide and very low tide. So in this case, when consider when the Moon is revolving around the Earth, when the Moon is very close enough, perigee, when it is very close enough, the gravitational pull will be very high tide. When it is very far, okay, it will be low tide. Similarly, when the Earth is close to the Sun, gravitation pull will be higher, high tide. When it is far from the Sun, gravitational pull will be lower, low tide. Okay, so high tide and low tide is also an interplay of Moon distance with the Earth and Earth distance with respect to that of the Sun. Okay, now with respect to this coral reef, very important. Okay, coral reef is quite important. Just try to understand. Coral polyps is basically the animals, and the algae is basically the plants, and the reef basically is the symbiotic relationship of coral and the algae. So symbiotic relationship is basically coral, which is an animal, provide protection and nutrients to the plants, that is algae, which is a plant, provide nutrients and oxygen to the coral, and in this way they both help each other. Okay, this relation is called as a mutualism, and thereby they colonize a region. Okay, coral is a marine animal, and they secrete limestone, and they are able to create this reef, which is where they can hide, where they can protect themselves. Okay, and the coral also gets this algae also gets protection because of that. Okay, so basically this helping each other, nature helps in each other's survival. Coral is that region, coral reef is that region which indicates a very healthy environmental condition, because they are very sensitive or living organism, and they can survive only in the very pristine condition. Okay, so algae, which is a plant which will be doing photosynthesis. Photosynthesis can be done only in the presence of sunlight. So coral reef are basically found in the shallow water, not in the very deep water. Coral is an animal, okay, and they secrete limestone and thereby create the reef structure. So this limestone is calcium carbonate, which is alkaline in nature. Okay, which is alkaline in nature. Some factors responsible for the healthy survival of the coral reef is shallow water, warm water, not cold water. They can tolerate 2 degrees Celsius plus and minus of the 20 degrees Celsius. Salinity should be there. They are not found in fresh water. They are not found in rivers. Moderate salinity, not very high. Clear water. Okay, clear water, not water which is having high sediments, or they even do not survive in the water with very high turbidity, pollution, they avoid. And symbiotic relationship between algae and the coral has to be there. So if these conditions are affected or disturbed, then coral will die, or the algae will die, and the coral reef structure will be like dead. There are basically three types of the coral reef: fringing reef, barrier reef, and the atolls. The fringing reef is the coral reef which is very close and parallel to that of the coastal area, and the barrier reef is basically it creates a barrier between the coastal area and the other part of the ocean, and in between there is a water body that is known as a lagoon that is formed. An atoll is basically, the round shaped structure which is usually found in the shallow water, but relatively in the interior. Okay, usually they are found in the ridges and all, it can be seen. Okay, so in the case of coral reef, coral bleaching is a very critical issues being faced by the coral reefs. So coral bleaching is basically whitewashing, and this happens because of some chemical reaction. What is this chemical reaction? See, carbon dioxide, which is an important greenhouse gas, this carbon dioxide when mixed with the ocean water, it forms weak carbonic acid, H2CO3. And this coral reef is made up of calcium carbonate, which is alkaline in nature. So when the acid and the alkaline material, they will react, what will happen is this coral reef will become weak. Okay, it will dissolve. Okay, and in that case what will happen? The protection mechanism of the algae, that will be lost. The protection mechanism of the coral, that will be lost, and in that case the small fish or the other living organism will going to hunt and eat. Okay, and over a period of time this reef structure will be without coral. Okay, so in that case the coral reef is very basically very colorful environment, and when there is no coral, wherein no living organism, it is going to be white in color because calcium carbonate is white. In that sense we use the term bleaching. Okay, so here for the conservation, for the protection of the corals, the bio-rock technology is being used. So we'll try to understand that bio-rock technology. So this is coral, very colorful. Okay, some facts. Coral, as we had studied, that they are found in the warm water, in the shallow water region, moderate salinity and sediments free. So coral is very, very important region because primary productivity in this region is very high. Okay, less than 1% of the ocean region they occupy, but they support 25% of marine life. Okay, most of the coral reefs are found in the tropical region, and 1/3 of the coral region of the world are found in Australia, Indonesia and Philippines. Okay, in the case of India, do you remember that east coast have delta? When the delta is there, sediments is there. When sediment is there, no corals. Okay, corals are mainly found on the west coast of the India. Okay, it is found in the Gulf of Kutch, Malvan, Lakshadweep, Gulf of Mannar and Andaman and Nicobar. Okay, so the question is, which one of the following have coral reefs? So Andaman, Nicobar, Gulf of Kutch, Gulf of Mannar, no Sundarban. Okay, big delta. We have seen types of the coral significance. Coral is very, very important because coral reef will be acting as a barrier or a breakage for the tide, cyclone, tsunami. For the food for the marine organism is also important. Food for the living organism, people living in those regions. Then tourism, medicine, all. Now in 2018, it was there in the news. Most of the coral reefs of the world are in the tropical water. Yes, more than 1/3 of the coral reefs are located in the territories of Australia, Indonesia, Philippines. Yes, coral reef host far number of animal phyla than those hosted by the tropical rainforest. Yes, see, coral reef occupy only 1% of the ocean area, but they support 25% of the ocean living organism. So it means they host or they help or they support, huge number of the living organism in the water. Largest coral reef of the world is found in the Australia, the Great Barrier Reef. Coral bleaching, we have just understood this. And for the conservation of coral, the bio-rock or the mineral acceleration technology is being used. Here what is being done is, see, calcium and the carbonate. This is what the reef is made up of, calcium carbonate, and this calcium and carbonate is there in the water. Okay, coral, they synthesize and then they form this reef structure. So it is naturally being done by them, and with the help of technology which is known as mineral acceleration technology, same mechanism can be replicated. How? By sending electrical signals in the water, electrodes, with the help of electrodes, okay, electrical current can be sent, wherein the calcium and the carbonate ions, can be fused together, forming the calcium carbonate. That is, the artificially you are creating reef. Okay, the entire reef structure cannot be created, okay, but this partially when it is being done. So in a hope that the corals will come and they will colonize from that point onwards. So that is under the pilot project. So biotechnology is talked about in which one of the following situation. So it is restoration of the damaged coral reef. Okay, so now with respect to this corals, you may expect a question, because usually UPSC focus on those area which is little critical in nature, which is oftenly there in the news, and having understood the basic, it is very easy that these area can be tackled. Now with respect to the fundamental of physical geography, we are left with the last topic, that is the world biomes. So we'll start with the world biomes now. So now with respect to the world biomes, we should be proceeding with the analysis of question. Here 1 or 2 concept based question UPSC have asked, and after that is individual question with respect to the world biomes. So question is with respect to the biodiversity and latitude and longitude. Okay, so the relation between them. The question is with respect to that of the tropical rainforest. Okay, and tropical rainforest, the soil in the tropical rainforest, and the rate of decomposition in the tropical rainforest. The next question is a similar question. This question in 2023 and 2021 is similar. In fact, it is a repeated question. Okay, here it is in the form of statement 1 and statement 2. Here it is in the form of a paragraph. Okay, so this question is also with respect to decomposition in the tropical rainforest region, why it is very fast. Then here the question is with respect to the characteristic of equatorial rainforest. Then tropical rainforest, if it is being cut down, then it will not regenerate very quickly. What is the reason? Then again, tropical rainforest, some data is given, and the question says, in this data, in this temperature and rainfall pattern, which type of vegetation will be growing? It is a tropical rainforest. Then insectivorous plants in the tropical rainforest. Some example of insectivore plant, epiphyte in the tropical rainforest. Again, tropical rainforest related question, if with respect to agriculture. Okay, so there are so many questions on tropical rainforest, so it is very important favorite area. Then with respect to the deciduous tree, this question will take it in the Indian geography, because it have got more relevance with the Indian geography, because deciduous tree we are going to, deciduous forest we are going to do in detail there. Of course, here also we'll do some basic understanding. Then leaf modification of the plant. Okay, again, leaf modification of the plant in the desert area. So this question is repeated. Okay, then grasslands in the savanna grasslands, and why the grasslands continue to remain, why there is no forest. This question and this question, in the grassland, why grassland continue to remain there, why does the forest does not grow? They two are again repeated. Now they see there are so many repeated question. Okay, then they have asked question, this fact based question, which is the forest covering the maximum area, lichens, symbiotic relationship. Okay, and the albedo. So the similar to question we had also seen in the climatology. So here the main focus of the topic is the tropical evergreen forest. The rest of the forest is quite easy and not very complicated question is being asked. So if they happen to ask, they may most probably ask question on the tropical rainforest. So let us quickly do this. So in terms of factors for the global distribution of the biomes, see, climate is a very important factor, okay, for the vegetation, and this climate important factor like sunshine and rainfall. Even the orography, that is the mountains, is very, very important. So with the increase in the latitude, sunlight decreases. With the increase in the altitude, again the sunlight decreases. With the respect to the rainfall, with the increase in the latitude or altitude, rainfall also decreases. So if I take this in terms of biodiversity is high in the low latitude region, and as the latitude increases, biodiversity decreases. Also altitude wise, at the low altitude, biodiversity is high. As the altitude increases, biodiversity also decreases. And this is a very close interplay with sunlight and availability of rainfall. Then with respect to the age, biodiversity with more age will be found in those regions where sunlight and water is available. Those regions where sunlight and water is not available, biodiversity would die very quickly. Now, equatorial rainforest or tropical evergreen forest, let us understand some characteristic. So, equatorial, as the name indicates, so some important things that should be known for each of these biomes is that one should know where is the global distribution, that where they are found. One should also know the characteristic, and some important examples, okay, is more than sufficient. Okay, so with respect to this, the climatical condition, features, global distribution, and the example, this is more than sufficient, and this must be continued for almost all the biomes. When the uniformity is there in terms of parameter, it becomes easy to study each one of them. So the tropical rainforest or the equatorial evergreen forest, they are relatively very, very tall, because they have to compete for the sunlight, and they are tall, and they grow and they spread so that they can capture maximum sunlight. So because of that, they form a continuous canopy, and at the bottom it is like mostly darkness, and this canopy is mainly in 3 different layers. Okay, continuous but different layers. Okay, and the leaves are very, very broad. Leaves modification is they are broad because they want to capture more of the sunlight, but from the leaves, water transpiration can also take place. Okay, but they are not worried about water loss because rainfall is every day in this region. Okay, so the stems is very, very hard because they absorb water continuously, and they become very, very strong. So at time, even the poison is given to kill the tree, so that it becomes weak enough, and then it is being cut down. These are mostly vascular plants, where there is this tissue, xylem and phloem is present, so that the water and food transportation takes place. So that's the reason why they're very, very tall. They're evergreen in nature. See, it's not like that the leaves do not fall. The leaves fall and grow, and it is continuous. So there is no specific season wherein they would appear brown or yellow. Okay, they continue to appear green throughout the year. Then there are some epiphytes. Epiphytes are those plants which take the mechanical support of the existing plant for their growth, and they grow above the canopy so that they can also get some sunlight. So they are there for the mechanical support. Okay, there are a lot of plants, animals, insect, and disease. So a lot of varieties can be found in this region. In this region, since the rainfall is everyday rainfall, so what happens is the nutrients in the soil, they get washed away. Because of that, the soil is nutrient deficient, and because of this, many problem arises. Agriculture becomes very, very difficult. When the forest is being cut down, secondary forest is difficult, means new forest do not go very, very fast because soil is nutrient deficient. Though biodiversity is high in this region, okay, but these are those biodiversity which is there for several years. Okay, means they have adapted to that living condition. But once they are cut down, the new the plants will find it very difficult for the survival, and they will die. So agriculture in this region, if this forest is being cut down so that cultivation can be done, soil is anyways nutrient deficient, so they cannot continue to do cultivation for relatively very long years. After 2-3 years, the fertility will be almost exhausted, and they have to keep on shifting from place to place for the cultivation. So shifting cultivation or the bush farming is a major thing that is seen over there, and it is a major problem also. Okay, secondary forest is not possible. See, consider this ecological succession wherein there was no life, then a climax community came. climax community, climax species. So equatorial forests are climax species when they are being cut down. So natural thing is again ecological succession starts. So that is a secondary ecological succession. But in the case of this region, soil is nutrient deficient. So what happens because of that? It becomes very, very difficult for the new propagules to grow. Here you can also see some carnivorous plants or insectivorous plants because soil is nutrient deficient. Okay, soil is nutrient deficient, and from the insects they fulfill their nutrient deficiency. Okay, from the insect they fulfill their nutrient deficiency. Then in this region the insects, disease, bacteria, all of these is very, very high. So when the leaves fall, the bacteria, they act upon these the plants, the dead remains of the animals, and they decompose them very, very fast. See, for the bacterial action, moisture is needed, moist condition is needed, and relatively warm condition is needed. Both these factors are available, so the rate of decomposition is relatively much faster as compared to that of the other biomes. Okay, so thick humus is formed. Okay, at the bottom, thick humus is formed. Some important examples are mahogany, ebony, rosewood, dyewood. Okay, these are very, very important species. Okay, if we proceed ahead with some important questions. So here you can see the leaf litter decomposes faster than any other biome, and as a result soil surfaces are often almost bare. Apart from these, vegetation is largely composed of plants form that reach up to the canopy vicariously by climbing the tree or growing as epiphytes rooted on the upper branches of the tree. This is most likely a description of, yes, it is the tropical rainforest. Next question, statement 1. See, this is the 23 question and you can see the repetition. Statement 1. Soil in tropical rainforest is rich in nutrients. They are poor, they are deficient in nutrients. Statement 1 is wrong. Statement 2. High temperature and moisture of tropical rainforest cause dead organic matter in the soil to decompose quickly. Yes, this is just we had seen in the previous question. This is correct. Okay. Then if you see this question, what is a unique characteristic of equatorial forest? Presence of tall, closely set trees with crown forming continuous canopy. True. Coexistence of large number of species. Yes. Presence of numerous variety of epiphytes. Yes. All are correct. If a tropical rainforest is removed, it does not regenerate quickly. Why? What is the reason? Because soil is nutrient deficient. For the vegetation to grow, soil must have nutrients, and this region is nutrient deficient. You can see some table is given. Average maximum temperature, minimum temperature. Can you see minimum temperature do not go below 20? Okay, so this is a region which is relatively hot, warmer region. And the rainfall, can you see, it is almost every month in the year. There is no month which is without a rainfall. And at the same time, can you see March, April time, and also can you see September, October time? These two season have relatively higher rainfall, so it is also the equinox time. So it is a characteristic of equatorial region, equatorial climatical condition. So there, which forest will be growing? Tropical rainforest. Okay. Some species of plants are insectivores. Why they are insectivores? Because soil is nutrient deficient. They are not able to get nutrients. So they eat insects. From there they get the nutrients. Okay. Then this question, unlike temperate forest, tropical rainforest, if cleared, can yield productive farmland that can support intensive agriculture for several years. Absolutely wrong. Okay, tropical rainforest do not have nutrient-rich soil. So how can they promote intensive agriculture for several years, and that too without chemical fertilizer? Absolutely wrong. Primary productivity of tropical rainforest is very high when compared to the that of the other temperate forest. So this is true. Now, tropical deciduous forest. What is the characteristic of deciduous forest? It is mainly found in the tropical monsoon climate where the rainfall is seasonal. When the rainfall is seasonal, so in that condition they shed the leaves when the rainfall is not there. So it is green during the wet period, it is brown during the dry period. Why do they shed the leaves? To conserve the water. They are mainly found in the Indian subcontinent. Example, sal, sesame, sandalwood, teak, bamboo. We'll do in detail the deciduous forest in the Indian biomes. Then comes the grasslands. Grasslands are very, very important. The grasslands grow in that region where sufficient water is not there and they cannot support the growth of trees. Okay, rainfall is relatively scanty. It's not zero. Okay, it's not very less. Rainfall is there, but at times it can be seasonal or very, very less. So in that region, grasslands will grow. So grasslands in the tropical region is this tropical grasslands. What is a characteristic? They are very, very tall. They are very coarse, difficult to eat them. They are seasonal in nature because rainfall in the tropical region start becoming seasonal as you go away from the equator. Okay, there is some scattered trees and shrubs. These are also described as parkland or woodland vegetation, and they are very, very important for wild animals. Okay, and for to see them, animal safari, also known as the big game country. Okay, so when the rainfall is seasonal, the grassland is seasonal. When the grassland is seasonal, animals cannot wait for the next season for eating. No, they are, when the herbivorous animal, they eat grasses. Grass digest very, very fast, so they need food continuously. Okay, so when the grass is not there, what will they do? They will migrate to that region where grasses can be found. So this region is also important for famous migration of the animals. So they are found in the Africa. In Africa, this grassland is known as savanna. In South America, it is known as Illinois and Campos. Okay, so here is a question and a repeated question. This was a repeated question basically. The vegetation of savanna consists of grassland with scattered small trees. The forest development in such area is generally kept in check by one or more of the combination of some conditions. So what is the reason that in this grassland area forest is kept under check? Means forest is not growing. So it is the limited rainfall. Okay, seasonal rainfall. Also grasses, when the rainfall is not there, they will dry up, and when they will dry up, they will catch fire very easily. They will catch fire very easily. On the other hand, let us say when the trees catches fire, so in that case, when the tree is catching fire, so it will be very, very difficult for the entire forest to grow, but the grasslands, they can grow very, very fast. So when the forest catches fire and when the forest is burnt, so next season the forest is not going to come again. It will take like decades, 2-3 decades for the forest to fully develop. But grassland, when this season they burn up, the next season again they will come up, isn't it? So season by season, every time fire will take place, and every time only grasses will continue to grow. It will not, ecological succession will not take place wherein it is going to get converted into forest one day. Okay, so forest fire and seasonal rainfall is the reason. Okay, and even the grazing herbivores, because herbivores animals, they they continuously eat. On the similar note, let us try to do this temperate grasslands. So temperate grasslands are found in the temperate regions of the world, and these grasslands are not seasonal. They are perennial. They are found for most part of the year. They are relatively short, they are relatively soft, and they do not have parkland vegetation, that is, they are without trees. So several kilometers, hundreds of kilometers, it would be only grasses, and they are famous. There it was famous for animal safari. Here it is famous for growing of the wheat and animal ranching, that is domestication of animal on a large scale. Some examples is North America prairies, South American pampas, Europe steppes. UPSC will ask question related to this mesocolumn kind. Okay, so you must mug up these facts. Okay, now let us proceed with the tropical thorny vegetations. So thorny vegetation is found in those regions where the rainfall is very, very less and the rate of precipitation is less, evaporation is more. So there is a water scarcity. When the water scarcity is there, so these plants will undergo some modification. That is, the height will be stunted, the leaves will be modified into thorns. The roots, since the rainwater is not there, so the roots, they fetch the groundwater. So roots have to be very, very long, and they have to store water. Since the leaves are small, where will they store the water? They store the water in the tree trunk itself. So the stems are spongy, that is succulent. Okay, and they are such characteristic to to survive in the less water condition are called as a xerophytes. Example, acacia, cacti, palm, etc. So you can see this question, again a repeated question. Which of the following leaf modification occur in the desert area to inhibit water loss? Hard and waxy leaves, tiny leaves, thorn instead of leaves, all are there. And you can see same repeated question, even the options are relatively similar. Which one of the following leaf modification occur in desert areas? Hard and waxy leaves, tiny leaves or no leaves, thorn instead of leaves. So answer is same. Then comes the Mediterranean forest. Do you remember one point about Mediterranean climatical condition? The Mediterranean climate condition, monsoon rainfall is in the summer, winter is dry, and here in the case of Mediterranean, rainfall is in winter, summer is dry. So during summer it becomes somewhat similar to that of desert like condition. So plant have to do some modification in order to survive in those conditions. So only those plants can survive which can tolerate long and dry summers, and in order to conserve the water, the tree trunk is having very very thick bark, the leaves are spongy, again the leaves are also waxy coated, fruits are also spongy, and the skin of the fruits are very very thick, and mostly the citrus fruits are grown in this region, and for that purpose viticulture is the major occupation. Okay. Now comes the biome, which is covering the the largest area in terms of the percentage. So temperate softwood coniferous forest, also known as taiga forest, also known as the boreal forest. Okay, so they are distributed in those high latitude region 50 to 70 degree north in the North America and Eurasia. You can see they are not found in the southern hemisphere. So they're mainly covering the northern hemisphere in 50 to 70 degree north. With respect to the feature, they are the largest terrestrial biomes on the earth's surface, and the trees are very very tall because here the sunlight is very very less, so they have to get more sunlight, and for that purpose they become tall and straight. They are soft and light wood because relatively water is less in this region. The leaves are small, the leaves are needle shaped, and the wood is very very important. Lumbering is a major activity, and the wood cutting industry, that is lumbering, helps in supporting the paper and the newsprint industry, shipbuilding industry, furniture. Good examples are pine, spruce, juniper, birch, cheer, fir, etc. Okay. A simple question, which one of the following covers the highest percentage of the forest area in the world? So it is the temperate coniferous forest. Okay. Tundra forest, so this is that region wherein very seasonal vegetation comes. See, tundra region is that region where winter is long and severe and mainly covered with thick ice. Summer is very short and cool, just for 2 months or 3 months, not more than that. So in the summer, when the ice melts, when the snow melts, so see, vegetation cannot grow in ice. For that it needs soil, and the soil will be available during the summer time. Summer is short and it is cool, so what happens is during summer the vegetation starts to grow. Okay, but summer is soon over and the winter comes, and again that vegetation gets covered by the snow. Okay, so these vegetations under the snow, they will die. Okay, so basically lichens, which is a symbiotic relationship between the algae and the fungus, mosses. Okay, these some vegetations are seen. Not this tall one, as you can see, this reddish one, these are the tundra vegetation. Now in tundra vegetation, some herbivorous animals are also found. So in the snow also they can dig, and they can find these vegetations underground, below the snow, and they can survive. Okay, even in the very snowy area. So here is the question, lichens, which is a symbiotic relationship. Symbiotic lichen, which is capable of initiating ecological succession even in the bare rock, are actually a symbiotic association of, yes, algae and fungus. Okay, algae and fungus. So now polar desert, lastly, it is that region which is permanently frozen. When it is permanently frozen, no vegetation is found over here. They are called as the biotic desert. No example for this. So now we have covered the physical geography of the world, wherein we covered solar system, geomorphology, climatology, oceanography, and the world biomes. So this UPSC can ask more of the fundamental question from these area. From Indian geography, they mainly ask mapping based question. So when we start with the Indian geography, we shall be there will be hardly any concept, especially Indian monsoon. There will be little bit concept. Most of the Indian geography will be map based. Okay, and I shall also be helping you with this year's current affair of mapping. Okay, so that in this revision series you have a more inclination towards that of the current affair mapping. Okay, so that there is probability that most of the question should come from this series. Okay, so we'll see you in the next session. Thank you.